found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Business go hybrid? When you're a chef running a kitchen,
artichokes, please.
Things can change quickly. The branzino isn't selling, the ribeye selling out. My floor manager's wife just went into labor. Getting things prepped beforehand can help you put out fires. Literally. That's what a hybrid cloud approach with IBM can do for your business. It lets you automate processes across all of your clouds to get ahead of problems and earn.
Hello everyone, thanks for joining once again and welcome to the WeAreDevelopers Live Days. I'm Seyat and I will be your host for this event. We are looking forward to 3 super exciting days full of sessions on various topics. We will discuss different frameworks such as Angular, React, Vue.js, Svelte. We will talk about TypeScript, about native script, micro frontends, also about GraphQL, Kotlin, and we will start now with a session about application modernization. If you are watching us from WeAreDevelopers.com live, then you can also join the discussion with your questions. There is a small Q&A tool besides the stream, and so feel free to join and engage. There's also already a first question for you. So where are you joining us from? And basically now, last thing before we start and quickly jump in, I want to drive your attention to our code of conduct. In short, it means we have to be nice to each other, treat everyone with respect. Here's a small video about that, and in the meanwhile, I'm going to get our first speaker on stage. Okay, welcome back and hello Niklas, how are you? Okay, and where are you joining us from?
Hey, Niklas here. I'm from Germany and I'm from Paderborn, right in the middle of Germany.
Oh, very nice. And tell us briefly, what will we learn from you in this session?
Yeah, today we have a really exciting session for you. It's about application modernization, and I'm going to talk about the main reasons why you should consider updating and modernizing your applications. And I'm going to show you how to get started with a step-by-step instructions with one comprehensive end-to-end example.
Okay, so Niklas, the stage is yours.
Okay, thanks a lot. So, okay, good. So the title of the session is Application Modernization and Rabbits, and I'm going to show you or explain in a minute why I chose the title. Again, my name is Niklas Heidloff. I work as a developer advocate at IBM, and I love working as a developer advocate because I can learn new technologies every day. And the best way for me to learn new technologies is to actually try them and to develop something myself. And that's exactly what I've done in order to learn the topic application modernization. So I've built this one sample that I'm going to use throughout the session so that every one of you can run all of the demos yourself right after the session. It's available as open source, and I'm going to show the link at the end of this presentation. So let's need to activate my screen here. Okay, so now, why did I choose the title application modernization, and rabbits. And in order to do that, to explain that, let me show you a really quick 2 minutes video that explains it.
Hi, I'm Niklas, an IBM developer advocate and part-time bunny keeper. Today, I'm going to explain the benefits of app modernization using rabbits. I got my kids 2 rabbits this spring. We put them in a simple cage and everything was just fine until we had a bunny explosion. A simple cage is like your monolithic app. It may be working fine until you have an explosion of requests, and then you need to modernize. This was a catalyst for us to modernize the cage and replace it with a structure of several hutches and pathways. Let's look at this structure as a microservices application. These hutches are connected with pathways, just like loosely coupled microservices. My end users are having a much better and faster experience with this modernized structure. When I need to repair one of these hutches, the rabbits can continue moving around, and similarly for a microservices application. If you need to fix or extend one of your microservices, you can replace it while your application continues to run. In other words, you are more agile compared to monolithic architectures. The other benefit of app modernization is efficiency. All kids can feed the rabbits at the same time, which means we are done faster. And now, I need to make sure that my end users are cleaning the hutches.
Okay, so that was the video. Now, there was a lot of information in this video. Let me recap quickly the main reasons why you should consider modernizing your applications. Number 1, more agility. Number 2, better user experiences. And number 3, reduced costs. In this session today, I will focus on the first reason, more agility. In other words, the ability to faster deliver new functionality and the ability to innovate. So there are, as I said in the video, there are a number of advantages that microservices-based architectures give you. The advantage that I highlighted in the video was resiliency. When you break down a monolith into separate microservices, the application cannot crash as a whole. You can update separate microservices independently from each other, and that's certainly one of the huge advantages of microservices compared with classic monolithic architectures. There are a number of reasons or a number of strategies how you can modernize your applications or how you can deal with legacy applications. Number 1, simply retire applications. And this might sound obvious or stupid, but in reality, what we have seen is that there's a big number of applications that is not used and people are just too scared to shut or to remove these applications. Number 2 is don't touch the applications. And again, that might sound stupid, but it's also a valid strategy, especially if you don't have the skills anymore that really allow you to make changes to the application. Number 3, lift and shift. This is certainly the easiest way to move existing workloads into the cloud. However, at the same time, it gives you some advantages, but not the full benefits of cloud-native applications. The good news about lift and shift is, and the reason why many people do that, is because you don't have to change your code. The 2 most exciting strategies, though, are 4, containerize, and 5, refactor. And these 2 strategies is what I'm going to explain in this talk. As I said, I built my own sample application, and I didn't build the original version. The original version was 10 years old, which you see here on the left-hand side. It comes with a web interface built with the Dojo toolkit, which was popular at that time. And on the right-hand side, there is a new modernized version of this application. Again, let's take a quick look how these applications work. Okay, so this is the Dojo-based version, and I should say it's an e-commerce application, a really simple one. There isn't a whole lot of functionality in it, but that's on purpose because I want to really focus here on the technology rather than complicated business use cases. So what you can do as an end user of this application is you can go to the shop or to the catalog. You can navigate through the different categories. You can choose one of the products, and then Back then, 10 years ago, you would use a drag and drop to drag something into your shopping cart. The shopping cart is displayed here in the right column, and there's also this order history tab. This is the new application. It's very similar in terms of functionality, right? You have the catalog again, or the navigator with the catalog on the left-hand side. You can switch between the different categories. And again, you can pick one of these items and add them to the shopping cart. And then the number of items in the shopping cart is updated in the navigator. And you can also go into the shopping cart to see the list of all items that you ordered. Now, this is the result of this modernized application, which I'm going to explain in this talk. As you can see, I'm not only having here one application or one container, I actually have, I don't know, 10, more than 10, 14, I think, different containers, and I explain most of them in this presentation. So let's go back to the slides right here. Now, before I really get started to explain how exactly I've done that, I want to make sure you understand that application modernization is a journey. It doesn't happen overnight. There is no magic, and it doesn't happen automatically. You have to really understand what you do. And my advice is take baby steps. Don't try to boil the ocean. Don't try to do too much in one step. Modernize step by step. Evaluate the value add and whether it was worth doing that step, and then continue. And the reason why I suggest that is because there's less risk that you break something. And again, you can see the actual value directly after every step. So in my sample application, I actually used 8 different steps. And this is too much to cover in only 30-40 minutes today, but you can go to the repo to learn more. Essentially, what I did was to use a 10-year-old application, or maybe 12 years, I don't even know anymore. It was built with Java EE6, and it was run on WebSphere traditional 8.5 running in a virtual machine. Then I moved the application over into a container, which gave me operational modernization or capabilities. In the next step, number 3, I actually updated from WebSphere traditional to a more modern Java application runtime, which is WebSphere Liberty. Step 4, I separated the front end from the back end so that I could easier change the UI or the web application in a later step. Step number 5, I changed from WebSphere Liberty to OpenLiberty. OpenLiberty is the open source version of WebSphere Liberty. It's basically the upstream project. Number 6 and 7, I used the strangler pattern, which I will explain, to really separate a certain piece of functionality, the catalog, from the monolith to be able to scale independently. And in the last step, I actually used micro front ends for the UI. And again, I'm going to explain why I've done that at the end of this talk. So let's take a look at the very beginning here, the starting point. This is kind of the high-level architecture. There are only 2 virtual machines. One is running the database, in this case DB2. The other one is running the WebSphere traditional server, and both the monolith UI and the monolith backend is really one application. So now, in the first step, I had to move the workload, the application, from a virtual machine into a container. And again, that allows me to benefit from operational advantages. For example, if all you have is a Kubernetes cluster or OpenShift, you can manage all of your workloads consistently. You can use the same monitoring, the same logging. You don't need any specific skills, any proprietary skills. And that allows you to manage and organize your applications much easier, even though you don't really benefit from, cloud native capabilities like health checks or, any advanced microservices technologies. In order to do that, I've used a tool that IBM provides. It's called the IBM Cloud Transformation Advisor. You can run this tool locally. It's just a Docker container, and it collects the data. And as a result, it tells you what you need to change. Again, in this step, I want to move my application from a VM into a container. So application transformation advisor shows you the places in the code that you need to change. And I'm going to talk a little bit more about that in a minute. And most importantly, it also generates these property files or these configuration files. Most important one is obviously the Docker file. right? So it tells you this is a Docker file and this is how you move from a VM into a container. And also there's a server XML, which is the configuration of WebSphere applications, WebSphere application servers. And POM XML obviously is what is used with Maven for dependency management. So all of these are provided for you, which makes this migration step or modernization step very easy. Now, I said you need, in some cases, also to change code. And we have another really great tool, which is called the IBM WebSphere Application Migration Toolkit. It's an extension to Eclipse, and it allows you to see all the places in the code that you need to change directly in your code. And here's how it looks like. In the first step, you define the configuration. So what I do here is to say, I want to modernize from a WebSphere application server traditional 8.5 to Liberty. I want to switch from Java EE 6 to 8. I want to switch from Java 6 to 8, etc. And then as a result, you get this. You get two Eclipse views. One is here at the bottom. That one shows you all the places in the code where you might have to do changes. And the Eclipse view in the right column shows you basically the help. You know, it tells you what and how to change things. In the easiest case, there's even sometimes a quick fix capability, which makes it even easier to change code. Okay, so I skipped a couple of details now, but essentially I've now moved from WebSphere traditional, from Java EE 6 to WebSphere Liberty. Now in the next step, I switched or I separated the UIs, and this is kind of what you see here. So now we have a data layer, a backend layer, and a front-end layer, basically a typical 3 tiers architecture if you want. And in order to communicate between the front-end and back-end, REST APIs are used. However, these are not RESTful APIs. You know, some people think that, or want everything that has to do with RESTful. In this case, I've used another pattern. It's called backend for frontend. So there are REST APIs, but these APIs are not really focused on resources, but they are really business oriented, and they give more optimized API, or they provide more optimized APIs for the front end. So there's a communication, between the UI and the backend using REST, but again, not RESTful. So now in the next step, I want to upgrade from WebSphere Liberty to OpenLiberty. Again, OpenLiberty is the open source version of WebSphere Liberty. WebSphere Liberty is IBM's commercial offering. One reason why I wanted to do that is because I'm a big fan of open source. Whenever possible, I want to use open source. That's one reason. Another reason, which might be even more important, is that I've heard, I'm not a salesperson, I'm a technical person, but I've also heard you can save some license costs. And maybe the most important point is that OpenLiberty has a great community. And as a developer, I want to be able to go to Stack Overflow or to the OpenLiberty website, and I want to get help. And this is certainly possible. There's a really big and successful community around OpenLiberty because it's based on open source that allows you to get support in many cases much quicker than any other option. So before I move on, let me be very clear. I think there are different options when you want to migrate or modernize an old, a 10-year-old Java application. There are certainly many options for the target runtime. It could be a Jakarta EE server, it could be Quarkus, it could be Spring, it could be other Java frameworks. My recommendation is, if you want to modernize a Java EE application, the best target is certainly a modern Jakarta EE application runtime. And the reason is because Jakarta or Java EE supports upwards compatibility, at least in many cases, maybe not all. I've seen some issues, but in general, it's much easier to update from Java EE to Jakarta EE. So that's the big advantage, and that's the reason why I've used OpenLiberty here as my target runtime. Okay, so in the next step, though, I want to show how to actually use microservices. So far, I haven't used microservices. I haven't really used cloud native. All I did was to move an existing monolith into a container and modernize the application runtime. I haven't really done any big code changes. I haven't really done any refactoring. And there's benefits, as I explained earlier in the video. However, at the same time, I want to make clear you understand that monoliths don't have to be evil. They are not always evil. There are good reasons why you might want to stick with monoliths. And a good example is certainly transactions. I think, it's much easier to do transactions that spawn multiple components in one monolith. It's also possible in microservices, but I think it's a lot more complicated in many cases, not worth it. Another reason why you might want to stick with monoliths is like if you only have, let's say, I don't know, 100 or a couple of 100 lines of code, it might not make really sense to split these two different things, because it's much easier to have everything in one place. But again, mileage may vary for you. But now let's move on and let's talk about microservices. Now, one good way to do that, to start using microservices, is using the strangler pattern. The strangler pattern can be used to identify the first microservice or the first microservices that you want to split from your existing monolith and run independently from the monolith. And I really like this pattern because it allows you to do changes in stages. This goes back to what I said earlier, take baby steps. Don't try to do too many things at the same time. And the strangler pattern is a really good way to just, identify the first microservices, the first microservice that could be independent from the monolith, so that, for example, you can scale these services and these applications separately from each other. In my case, in my example, this makes a lot of sense because the catalog is primarily used by users, or most users use the catalog only. Let's put it this way. Most users only browse through the catalog, and only few users actually start the order process. So it makes a lot of sense to be able to scale the catalog service independently from the rest of the application. And this pattern is actually something that I didn't invent. It has been around for a long time. And as often, Martin Fowler was the first one who wrote about it. Now, in order to identify the first microservice that you want to separate or split from your monolith, there are different approaches. One approach that I really like is yet another tool that IBM provides. It's called Mono2Micro. The way this tool works is that you point it to your existing source code, the source code of the monolith, and it reads all the classes and methods and dependencies and so forth, but also it evaluates the invocation hierarchies or chains of method calls at runtime. So the way you do that is you define use cases, so the typical things end users would do, and that is measured as well. And Mono2Micro basically creates a proposal for you or recommendation how you want to split your application into multiple parts. So what you see here, and let's ignore everything on the left-hand side. Let's ignore everything here in red and blue. Let's just focus on the red, the purple and the green circles here. Everything in green is basically the remaining monolith, right? Ordering and so forth, histories. And everything in purple is the catalog. So basically, Mono2Micro basically confirmed what I told you earlier. And this is exactly what I wanted, right? So it's a really great tool that helps you to identify the first microservice that you might want to split from the monolith. Now, the important thing here is that you need to minimize the dependencies between these different rectangles. And I should say one more thing. The reason why these rectangles are called partition 0 and partition 2 is because Mono2Micro uses AI internally. And these are terms that data scientists, etc., use. Now, as a developer, you might expect rather something like microservice 1, microservice 2 or something. But that aside, the result is pretty good. Now, again, back to what I started to say, or started to explain, the dependencies between these rectangles, they have to be minimized. So in this case, it's actually rather good. There's only 2 lines between the purple and the green circles. And that's good because you don't want to create microservices for the purpose of creating microservices. What you really want is to decouple certain components within your application. And that is achieved by having as little dependencies as possible. Because what you really don't want to do is to build distributed monoliths. And this is something that I've seen a lot. People have heard about microservices and they just want to try it and they start, breaking down a monolith in 5 microservices. But all they really have at the end of the day is often distributed monoliths where microservices have dependencies and invoke REST APIs between each other in a synchronous way, in a blocking way. And this is certainly an anti-pattern, something you really need to avoid. Now, I think the best reason to avoid that, or at least to mitigate that, is to use event-driven architectures. And this is something, again, that I've used in my example as well. So rather than invoking synchronous REST APIs, I use here Kafka as a messaging service in the backend. And let me show you, I think, oh, actually I have, before I show the architecture slide, let me show you how this looks like in the UI. Okay, so this is the modernized version. And what I do here, one second. Oh, no, that was not it. 1 second. That's the right one, sorry. So that's a video. Okay, so this is the modernized UI. I can go into the shopping cart, and the price is now $29.99, Return of the Jedi. And when I invoke here a REST API, a put call command to update the price to 50, and then I see the price change right here in the shopping cart. And this even works for the old UI. So there's also the new price 50. Now, what you just saw, let me go back to the slides. Okay, so what you just saw is a dependency between the catalog service, the microservice, and the remaining monolith, because really only the catalog service knows the current price. But in order to show the shopping cart, the remaining monolith needs to know this information. Rather than invoking the catalog service synchronous whenever this page is displayed, I use caching to store this information redundantly in the DB2 database. Again, the DB2 database is what is used by the remaining monolith. And what you can see here on the right-hand side is that I added a new column called price current. So I use a simple caching here in order to minimize the dependencies. And this is the resulting architecture. So again, we still have one monolith in the front end, but then we have the catalog service, the first microservice that we separated out. That one I implemented with Quarkus. The remaining monolith can still run on OpenLiberty or with Quarkus. I have actually two versions of that same service. The remaining monolith continues to use DB2. The new microservice, the new catalog microservice, uses Postgres, and they communicate asynchronously via messaging and Apache Kafka. So when you modernize applications, one of the questions I hear a lot is, what target application server or runtime should you use? And I started to talk a little bit about that. I said, if you want to modernize Java EE, then by default, you should look into Jakarta EE runtimes, right? That makes a lot of sense because of the upwards compatibility. One other thing you really should take into account is to pick a good JVM. And one JVM I want to highlight here is the one that IBM open sourced 2, maybe 3 years ago. It's called OpenJ9. It's available again as open source. And it's really efficient for container workloads because it was designed to run on really small handheld devices. So it consumes a lot less memory compared to other JVMs, almost half of the memory only, which is a lot of money, especially when we talk about cloud. Another thing you should have in mind is that in order to build new and modern applications, reactive technologies are becoming more and more popular. And as part of my sample, I've used reactive technologies to show how to even implement reactive REST endpoints and how to access data in the database reactively, or in other words, asynchronously. And that gives you huge efficiency benefits and gains. And this is something you really might want to look into. And that's actually the reason why I've used for my Quarkus implementation, for the catalog implementation, I've used Quarkus. And here are some examples. So I've implemented the same REST endpoint twice, both times using Quarkus. Once I implemented it reactively. This is what you see at the top. And once I implemented it as you would do it classically using imperative code or synchronous code. And I've invoked in this example here, I've invoked the same REST API 30,000 times by simulating, I think, 100 or 300 users. And you can see the response time goes down from 1 minute 18 to 45 seconds. So this is a huge gain and a huge efficiency benefit. And this is one of the things why I really like Quarkus so much. I'm a big fan of Quarkus. Quarkus is a new, relatively new Java framework. I think it had recently the 2nd anniversary. There's lots of reasons why I love it. It's a lot of fun to work with it. There's good documentation. There's a lot of progress, a huge community, and it comes with a reactive engine. It comes with Eclipse Vertex built into Quarkus. So you can use this functionality out of the box without really having to include anything else. And again, this makes your applications much more efficient. Not certainly something for all modernization projects, but certainly something you should consider when you start implementing new microservices or when you start adding microservices to your existing monoliths. Okay, so now let's come to the last part of this talk. I've talked and explained how to basically use microservices in the backend. And again, many reasons why you want to do that. The main reason is you can update these microservices separately from each other. However, that only makes sense if you have the same architecture or the same design, not only in the backend, but also in the front end. And here's the use case. Let's say you want to add new functionality to your catalog service. Let's say you want to add ratings to your products, for example, number of stars. Then it's not good enough to just change the catalog backend microservice, but you also want to be able to change only that part of the UI separately from everything else. Because if you modelize your application in the backend and still have a monolithic front end, you don't really gain much. You really want to be able to modernize all of these things and update all of these things separately. And in the best case, to even have separate CI/CD pipelines to do these changes. And this is actually exactly what I've done. So this is the last architecture slide here. And as you can see, I separated or I split the one monolithic front end in 6 different so-called micro front ends. And here's another diagram that shows maybe better what I've done. So this is the new modernized UI. And I've used here Vue.js to implement these different visible these visible micro front ends. So I have the navigator, and then dependent on the selection of the navigator, I have the catalog, the order, and the account micro front end displayed in the right column. And there's actually 2 more non-UI components or non-visible components, the shell and the messaging component. Now, as I said, for the visible components, I chose Vue.js, but you could also use whatever you like, whether that's React or web components or vanilla JavaScript or Angular, whatever you like. And then the 2 non-visible components, the shell one, that one basically defines the layout, and it makes sure to load all of these other micro front ends that you need. The second one, the messaging one, is a little bit more interesting. And this is basically the counterpart to Kafka in the backend. What I just talked about, the communication between the microservice and the remaining monolith, you want to have the same decoupling in the front end. And that's why I use RxJS, which are the some extensions, some reactive extensions for JavaScript. For example, you have objects like observables. And this is how I do communication between these different micro frontends. For example, if you browse through the catalog and you add an item to the order list or to the shopping cart, you need to communicate between the catalog micro frontend and the order micro frontend. And again, you don't want loose coupling, you don't want synchronous invocation calls, and that's exactly why I've used here RxJS. This is just a screenshot of how this application looks like from a developer point of view. So the framework that I've used is called Single Spar. Single Spar is a framework that allows you to pull all of these different micro frontends together in one place. And there are other alternatives. So Single Spar is not the only one, but they all work kind of similarly. They basically federate or aggregate all of these different micro frontends in the front end, in the browser. You can think of it, basically like in the backend when you use Node.js or JavaScript in the backend, you can say, export and import. And the same functionality is now with the modern browsers and also with polyfills if necessary, also possible in web browsers. And this is what a developer would see. So right here, you can define exactly where to load which micro frontend from. In general, or by default, that would probably be all from a server, from a file storage or cloud storage, whatever, object storage. But then you can override different or separate specific micro front ends with local Node.js code, with local Vue.js code. So very powerful. And again, I don't have the time to go in more detail today, but all of this is documented and it's working in the repo. Okay, so let me do a quick time check. Okay, good. So this brings me almost to the end here of this talk. So we have a little bit of time for questions and answers. I recommend, if you want to learn more, check out the repo. It's in the IBM GitHub organization, and you can just search for application modernization, or you can type in the whole URL here, application modernization, Java EE Quarkus. I've written a series of blog entries about it. I think more than 20. There's videos, there's some samples and blogs and everything. So there should be a lot of documentation already available. We are also working on creating workshops so that you can run these things, in a step-by-step fashion. And I've also spent a lot of time to really make it easy to use this example. So what I've done here is to implement a whole lot of scripts to install and run the example. At this point, I'm using Docker Desktop. You need to make sure that you have enough disk space and CPUs and memory. But other than that, all you need to do, as you can see here, is one git clone and to invoke one single script. There's also more scripts to run and delete single services, etc. Very easy to use. What I'm working on right now is to extend this example to also deploy it easily to either Kubernetes or OpenShift. OpenShift is the enterprise distribution of Kubernetes. And I want to have some CI/CD pipelines using Tekton, Argo CD, etc., GitOps to really deploy the same example also very easily to different Kubernetes and OpenShift distributions. So I think that's everything that I had for today. Thanks a lot for your attention. And now we have some time for questions. Do we have any questions? Let me check on Slido.
Hello, Niklas. Thanks for your presentation. It was a very cool overview of the possibilities. We do have 2 or 3 questions already on Slido, hopefully more coming in, yeah. Let's maybe start with the first one about micro frontends itself. What do you think? Are there any limitations of using them?
To be fair, I think yes. I mean, the challenge that I had was really the overall layout. Things like if you use, for example, standard frameworks like Vue or React, they give you things like a router, that they give you things like different navigators, they give you things like responsive designs, all these kinds of things, and they they can still continue to work if you use them in the right way, but you cannot assume that they all just continue to work, because I mean, remember, you basically pull different web applications together running in one web browser, right? And there are some collisions. Like I would also suggest to do certain things like make sure you only use one framework. Don't mix React with Vue or Angular or something. It doesn't make sense in most cases. Plus, you will only add a lot of data that needs to be loaded, or the resources, the JavaScript, HTML, CSS, etc. So I wouldn't do that. I would also recommend to have yet another of these shared components that I talked about, where you store all the CSS and styles, etc. Right, rather than doing it in these different micro frontends. So I don't want to lie. It's still challenging. Like there is not the one magic trick to make everything work in a micro front-end kind of fashion. But I think if you have it in mind at the very beginning, there's quite a number of things that you can do easily. And what I've done actually works. So all I did was to really build the one HTML page. And in this one HTML page, I defined my, basically a little table or so with a navigator in the left, with the other 3 components in the right. But that's something you need to do manually because you can't solve that generically with a framework like single spar.
Okay, thanks, Lawrence, for the question, and also thanks for the answer. Then the next question may be a bit connected and a bit generic. Does it make sense to migrate existing projects to micro frontends, or is it a hassle?
Yeah, it's kind of related, right? There is not the one simple answer. I would certainly recommend to look into micro frontends, because there's clearly a lot of benefits. But similarly to what I said earlier, right? Microservices don't always make sense, or in other words, monoliths are not always evil. Like if you have a web application that isn't too sophisticated, right? There's probably no reason to break it down in different parts. But it depends. If you have like an development organization with hundreds of developers, it might make a lot of sense to break down these things so that you can manage and evolve these different parts much better. It really depends on your requirements. All I can say is take a look at these different alternatives. Single spar again is what I've used. Play around with it and see whether it works for you.
Yeah, maybe a question from my side. I mean, you mentioned, or your example was with Vue.js, and we know that also in Angular you have quite some support and always new things coming. What would you say from the front-end frameworks that you have right now? With which one is it the most easy way to start with, or the less hassle?
Oh, that's a trick question. Because everyone has different preferences. It's almost a philosophical question. I'm a big fan of Vue.js because to me it feels like it brings together the best parts of Angular and React. Other people say, you really don't want to use Vue.js because there's only one single developer, which is true and not true at the same time. There's no big company behind it. Others say, really use web components, but that's a story that I've heard for the last 5 years, and it's always like, wait another year. I mean, I don't think there is a good answer. Check out the different alternatives. I mean, it's always good to learn something new, but it might also help to just stick with what you have and the skills that you have. Again, there's no easy answer.
Yeah, that's interesting. We will also have some other sessions today, but also the upcoming days, also about micro frontends and also about Angular Webpack and micro frontends and also web components. I think this afternoon. So yeah, I think there is always multiple ways, right, to achieve something. Let's go to the next question. Andri is asking, can you please tell us if Jakarta EE9 is already supported for this approach?
Yes, it is since recently. So okay. OpenLiberty does support Jakarta 9 and MicroProfile 4, for example, and I'm sure there's other application service by now.
Okay, perfect. So I think this was the last question. Niklas, is there anything else you would like to share? I mean, you already pointed out some references and how to get started. Do you have any thoughts on the future, like on what will change, what will come into addition to support, and some thoughts on that?
Yes, so one thing I want to mention is that IBM provides a really great IBM public cloud, and there's a trial account which you should check out because there's no time restriction. You don't have to provide a credit card, and you can play with lots of services. One of these services is actually Kubernetes. There's a trial account or a simple lightweight cluster that you might want to try out so that you can run all of these in a real Kubernetes environment, because I think in most cases the target environment for what I just talked about is Kubernetes, right? I haven't really spent much time today to talk about it, but that's really what you should think about first before you start the journey into the cloud. You should understand the target, right? The target environment, and this is something you can just try out on the IBM cloud. There's also our website, IBM Developer. We have an entry point or a starting page for containers, another one for Java, tons of materials and what we call patterns or samples, workshops, etc. So lots of ways to really get started and learn this technology.
Yeah, I would also advise everyone, if you're interested in the topic, please just maybe Google for Niklas or visit the IBM developer page, or search on YouTube for these topics. I'm think there were already a couple of weeks ago we had another session with Niklas about some other topics. So it's very, very interesting to learn about it, and I think also that the IBM developer page is a good way to start, where you have really also agnostic from like, you know, the platform. Also a lot of content that is very useful if you want to deep dive into these topics. Niklas, I have to say thank you. It was really a cool session. Thanks also
thanks
for
a
the
lot.
nice videos. And I hope to see you in the future again.
Absolutely. Thank you.
Perfect. Okay, bye-bye. Okay, so this was the first session for this afternoon. We will now do a very short coffee break, around 15 minutes, and at sharp 2 p.m. we will start with our next session about rethinking reactive architectures with GraphQL with David Leitner. Very much looking forward to that one, so take the time, grab a coffee, and see you in a couple of minutes again.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
As a coach, my offense is nowhere without a solid line and agile, skilled players. I need the speed of a running back and the security of a lineman. A hybrid cloud approach with IBM gets your business both, so you can manage data and apps, whatever plays come your way.
Here, coach.
When security meets agility, you're unstoppable. Bring it in, guys, bring it in, bring it in. 1, 2, 3, I'm ready!
Hello, welcome back. I am here with David Leitner. Hello, David, how are you?
Hi, I'm fine. I'm super excited to be here.
Okay, great. Where are you joining us from?
I'm joining us from Vienna, from the third district, from my home office today. So I can imagine
Okay.
you can see it, yeah.
That's not far away from the studio, yes, but there are some blocks between. So tell us, David, what will we learn from you today?
We will dive into the concept of reactive architectures. So we will go through it on a conceptual level. What does it actually mean? I will try to pick up everybody who has already experience in reactive programming, reactive architectures, and then we will go into concrete use cases to really see the full power of them, also in combination with GraphQL. Yeah.
Perfect, David. Happy to have you here. So the stage is yours.
Enjoy.
Cool. Hi. Nice to hear you, at least, hopefully at some point in time. Nice to see you also, that so many people are joining online. It's fantastic. I'm really thrilled to talk about rethinking reactive architectures with GraphQL today. I talked a lot about front-end architectures, a lot about reactive programming, a lot about the concept of GraphQL, and now I finally have the opportunity, or WeAreDevelopers invited me to talk about all this together in one single session, to streamline all this to one session, streamline perfect wording in this context. So I'm really happy to guide you through this in the next 45 minutes. Yeah. But first things first, my name is David Leitner. I'm coming from Vienna. Maybe you can hear it also on the voice. I'm located in Vienna. I'm working for a Viennese company as a coding architect. So we do a lot of technical consulting, reactive microservice architectures, GraphQL and Kafka, modern web platform tools like React, Svelte, and so on and so forth. But the main goal, beside all this technical excellence we usually bring, is that we want to help the customer to build great products. And we do this by classical technical consulting or by really providing full teams that can bring technical or digital initiatives forward. Yeah. And one thing we realize very often these days, that reactivity, reactive architectures, reactive programming, all this reactiveness we see currently in software engineering is kind of a very interesting, I would call it, buzzword for many. And I would like to dig a little bit deeper into the concept of reactivity. Because if we talk about reactive architectures, we first of all need to understand what reactive basically means. And as I said, we see reactive very often these days. We see it in React. Well, already the name says it's kind of reactive. Also, the logo shows a little bit of reactivity. We see Project Reactor in the Spring ecosystem. We see reactive extensions to provide reactive extensions for most of the programming languages we have these days. So it seems there's a little bit of buzz, a lot of buzz actually, I would say, going on in this directive. So what does reactivity actually mean? It is nothing else than programming and designing upon asynchronous data streams. Yeah. And to understand this, we really need to start with the basics. We really need to understand what is an asynchronous data stream. And many of you for sure will understand it. They say, okay, I know streams. Yeah, but for many, or at least this is our observation in the daily doing, streams are still kind of a, not so well-known term, kind of a woohoo term where people do not always know what we really mean by streams. But streams are a very natural things, yeah? A very natural thing, because if you think about programming on a very abstract concept, yeah, then we have data containers on two different axes. We have them on space and we have them on time. Yeah. And if we now think in singular space and in synchronous time, then we have a data container which we tend to call a value. Whoa, a value, yeah, mind-blowing. But basically a value has a getter and a setter. If we now move in space from singular to plural, what we usually have is kind of a collection with an iterator and a generator, right? These are the basic ideas. Every programming language supports this out of the box, so we have this concept nearly everywhere. Yeah. If we now move from synchronous time to asynchronous time, which means that we do not get data directly once we request it, but we get it after some time, we usually have something in singular space, but in asynchronous time, which we tend to call promise. Because a promise promises us that it will provide us some value in the future. It doesn't tell us when, but it promises you will get it at some point in time. Yeah? If you ever worked with promise, you know that this promise is not always true, but many programming languages, many ecosystems come with promises out of the box. So JavaScript, for example, has native support for promises. In Java, we have computable features. So we see promises being baked into most of the languages. But if you now go from singular space to plural space and from synchronous time to asynchronous time, then you ultimately end up in the world of streams. So streams are natural. If you take a look at this graph, you see a stream is a data container which exists, which always existed, right? But people now start to use them more often. And we see that many programming languages, many ecosystems didn't come with native support for streams. This is why we introduced reactive extensions, where we provide reactive data containers for nearly all programming languages. But we see a lot of ongoing initiatives in most ecosystems. For example, Java Project Loom with virtual threads, which actually is just created, or one of the main goals to create this is to support reactive programming better in the Java ecosystem, right? So these are streams, right? Very simple, just a basic concept of a data container in asynchronous time and plural space. But what has this all to do with reactive programming? Because before we go into reactive architectures, we need to talk a little bit about reactive programming and the goals behind it. Well, let's start with a very simple example. Let's start with the idea of 3 lines of code where we have a counter, where you have doubled, and the counter is set to 1, and doubled is counter multiplied by 2. So doubled in this situation would end up in 2, right? If we now change the counter to 3, what will happen? Well, basically nothing. Well, we set the counter to 3, but the doubled still stays at 2. So if we want to update the doubled, what we actually need to do is we need to reassign to double counter multiplied by 2. And this relation between counter and double is implicit. It's just an idea in the mind of the programmers. But it should be baked into the language. It should exist for all time. That's the request from the reactive community. So they say the counter and the double should be bound, right? And one very old idea in reactive programming is the so-called destiny operator. Yeah. There's lots of writing about destiny operator and how it could be implemented. Here, just see a simple example on line 2, where we say, okay, double is bound to counter multiplied by 2. You see, it's not just an equal sign, it's the destiny operator here. And if we now set the counter to 3 and then check doubled, it will be 6, because we bound double always to the current value of counter. And if this is just an abstract example, let's take a look at real-world example, because we already, as I said, many of us do reactive programming on a daily basis. If you, for example, work with Angular or with other reactive extension tools, we can use these concepts, but they always work with kind of a stream under the hood. And this is why I showed you streams before. Because if you now take a look at this, what usually happens is that counter is a stream, right? Counter is a stream with an initial value of 1. And doubled is a transformed stream. We take the counter stream, transform it, map it. So take each value, multiply it by 2 and get another stream. In this situation, the stream would have the value 2. If you now assign a new value to counter, for example 3, we will put this value into the existing stream counter, and this will automatically update the double stream, because it's just subscribing to the previous stream and transforming it by map, and then putting 6 into the double stream. So this is how the destiny operator is usually implemented. And as I said already, some of us are working on a daily basis with this already. Because if we now go and say, okay, doubled is 6, right? Because we updated the counter in a way to 3, and doubled will be 6. In real-world examples, as said with RxJS, this would look like this. We would have a behavior subject with an initial value of 1 on line 1. So this is a stream with an initial value of 1. We will have a doubled, which is just a transformed stream of counter. So we take the counter stream, map it, multiply it by 2, all the values within the stream. And if we change the counter, we just emit a new value to it, in this situation 3. And if we then assert it, we will see double valued is 6. And that's reactive programming in its heart, by using streams in the form of Rx JavaScript in this situation. And more modern frameworks even bring this a step further, because you see it's kind of verbose here. And for example, Svelte, a very modern web framework these days, tries to introduce the destiny operator in a very simple but beautiful way. To just say, okay, each value which is prefixed with the $sign will automatically be bound. So in this situation, double will be bound to counter because we put a $sign in front of double. And that's the main idea of reactive programming. That's all it is, right? So we make this binding between values explicit. So the reactive programming paradigm is based on asynchronous streams which propagate change. So when we want to propagate change, we talk from a caller to a stream, and we observe from the receiver the stream. And whenever we kind of need a change, then the receiver automatically gets pushed instead of needing to pull this change. So if we move this concept a little bit higher to a concrete example of software design, let's assume we build a mobile client, a mail client. Yeah? Let's assume we build a mail client like Gmail or many others, yet another email service, right? And let's assume on this email service, you see the emails which the user has. So in this situation, we have one new email, a list of emails, and at the bottom, we see the amount of all emails. So if we now want to reload those emails, we would introduce a reload button, right? This reload button would actually go to kind of a controller. This controller would maybe store the current emails, would then go to a REST client, would ask for new emails, would update its records of emails, and would kind of trigger the UI to update. It would go to all the UI elements that are interested in these emails and would say, hey, cool, update this UI element, update this UI element, and update this UI element. If you would build this in a reactive manner, the first thing that would change is that you basically, I guess, wouldn't have a reload button because you would have a stream. And this stream would contain all the emails that are relevant for your service. And what we basically do is we, as I said before with this, or as I showed before with this simple map operator, we would simply map or defer the stream to specific streams as we need them on the UI. So this transformation looks, for example, in this situation, just by subscribing to the stream and making a count on the stream so that we see, okay, there are 4 emails currently in the inbox. In this situation, we would just say, okay, let's collect all the emails in the stream and let's map them. So instead of showing the JSON email, we would transform it to a single line, which can be easily shown on a mail client. And in this situation above, where we show the amount of new emails, we would filter the new ones and would then count them, right? So we'd always just subscribe to a stream, transform the stream in a way how we need it on the UI, and would bind to this new stream from the UI. And when a new email arrives, we wouldn't use a REST client because REST is always pulling. We pull for data. We ask, hey, is there a new email? Is there a new email? No, we would maybe use something which supports pushing us new emails. And this would, for example, be a simple WebSocket client, which sends us whenever a new email is available, this email into the stream. And automatically everything will update because we're just subscribing to the stream. And whenever a new element in the stream arrives, we don't need to do any manual updating because we just subscribe, right? And every new email there will automatically trigger all the derived streams and will update the UI from our perspective. So if a new email arrives, all these UI elements will be automatically updated. And that's actually the power of asynchronous, of reactive programming, right? Because we move from pull-based design to asynchronous push-based design. Yeah? And that's the idea of reactive programming in its heart. That's basically it. It's not super complicated. Whoever tells you it's super complicated wants to sell you something. But that's the idea, moving from pull-based design to push-based asynchronous design. So for those of you who didn't know reactive programming, I guess you have a basic understanding now. But for the others, they are maybe disappointed because they, hey, we didn't read reactive programming in the title, we read reactive architectures. Yeah. So please finally start to talk about reactive architectures. Yeah? Well, as so often in software engineering, when we try to reuse concepts, yeah, we start on the software design level. In this situation, we start with reactive programming. But we try to move these concepts up. We try to move the same concepts actually to the software architecture level. And this is why we tend to call these things reactive architectures. And that's a very important point because we see this very often, taking the same concepts we have on software design and applying them to software architecture. And so we take the same concepts from reactive programming and basically just move them up to system architecture. And this is where reactive programming actually becomes reactive architecture. It's the same idea. It's just applied on different levels of software engineering. Yeah? And we do this and hope for the best that it works, right? And basically, we found out that it works very often. And if we talk about reactive architecture, it's worth taking a look at the Reactive Manifesto, which is around for a couple of years already. So you see it was published in 2014. And it's a very basic concept. It's a very guiding principle when it comes to reactive architectures. The problem is if I go to clients and ask them, hey, let's talk about reactive systems, and they already started to build something maybe. I asked them, did you read the Reactive Manifesto? Did you understand it? And they said, yeah, I read it, but there is on the second page this kind of very complex graph which shows lots of errors, and it's a little bit hard to grasp. Yeah, and maybe it is. I don't know. But usually I try to explain it to them in a way that they understand it in a very short amount of time. Yeah. Because it's the basic idea of reactive systems. You need to understand the Reactive Manifest to understand the concept of reactive systems. So I will try to explain it to you even faster. Yeah? So what the Reactive Manifesto actually says is that the main idea behind reactive systems is that they are responsive. So responsiveness, as so many others, is a non-functional requirement. A system could be elastic, a system could be scalable, a system could be maintainable, a system could be testable. But if we will build reactive systems, our main goal is that we build them in a responsive manner, which means that the user always gets feedback if he talks to the system. He always gets a response. And we see that this non-functional requirement of responsiveness is getting more and more important in modern software engineering. So why is this the case? Why is it so more important than, for example, 10 years ago? Well, 10 years ago is a good number, because if you take a look at the internet 10 years ago, 2010, the internet had 1.4 billion users, right? 2020, the internet had 4.7 billion users. Facebook has 2.8 billion users. YouTube has 2.1 billion users. What does this basically mean? This means a single website may now handle twice as much traffic as the entire internet did a decade ago. And that's fantastic on the one hand, but on the other hand, it's scary. And it also tells us that our systems architecture needed to change a lot in the last 10 years, because we needed to fulfill new requirements. In this situation, responsiveness, scalability, and of course also extendability. And those three non-functional requirements are perfectly well supported by the Reactive Manifesto if you build reactive systems. And what the Reactive Manifesto now says, okay, if you want to have a responsive system, you can achieve this by two means actually. By building it in an elastic way, which means that we can scale out the system instead of just scaling up, right? So back in the days, we moved more processors, we moved more memory into our system. So we made the one system better. Now we try to just deploy the system multiple times. So we moved strongly from scaling up to scaling out. Yeah? And the second mean to support responsiveness of our system is to build it in a resilient way, which actually means that if a part of the system is not working anymore, the overall system still works. So these two means mainly support the non-functional requirement of being responsive. And now comes the glue behind the Reactive Manifesto. Because the guys from the Reactive Manifesto say, if you want to be responsive, you need to be elastic and you need to be resilient. But the cool thing, if you want to be elastic and if you want to be resilient, you can easily achieve this by going into a message-driven architecture. Because message-driven supports being elastic, supports being resilient, and ultimately supports being responsive. Okay, what does this even mean now? Let's take a look at concrete examples. Yeah, very high level. We will go into more sophisticated examples later, but just to get the point. Yeah, let's take a look at elastic first. Let's assume we want to support the elasticity of a system by going into message-driven architectures. Well, let's assume we have microservice A talking to microservice B. Very simple use case. And let's assume we want to scale out microservice P. So we want to have 2 instances of microservice P. Then microservice A suddenly needs to decide to which instance do I need to go. We can introduce load balancers or other tools, but if we go with message-driven architectures, if we just put a stream between those microservices, the problem is solved, because microservice A sends a message to the stream, and whoever is currently interested which instance of microservice P just picks up this message, works on it, and maybe sends back another message. So just by introducing message-driven architectures in the form of a stream or a queue, you can easily achieve the goal of building systems in a more elastic way. And then we have the second part of the coin. We have resilience. So microservice A, again, talks to microservice B. Let's assume microservice B has high latency. It's not motivated. Bad day for microservice B, down, right? Then we are blocked on microservice A because we talk to microservice A in a synchronous manner. We say, hey, give me some data. And as long as microservice A is not responding, we are blocked on microservice A. And as soon as microservice B responds and we get the response on microservice A, we can continue with further requests. By just, again, applying the same recipe, putting a stream in between, we can easily solve this issue. Microservice A sends a message to the stream and it's done. That's the whole idea. Microservice A can work on other stuff because I forwarded the message now to the stream. Whoever is interested should kind of pick it up and should work on it. Microservice B takes this message, and once it's done, it sends back the message, and microservice E kind of subscribes maybe to the response. And this is what we tend to call back pressure and location transparency. On the first example, you saw that we support back pressure now. If we have a bottleneck, if we have a latency part in our system, with back pressure, we don't move the latency down to the first caller. We isolate the latency. And with location transparency, we get the easy advantage of being able to scale out because the provider doesn't know the consumer anymore. So we can easily scale out because we have the stream as an interaction in between. So we decouple the systems. So we support location transparency and we support back pressure. And now this slide looks similar than the slide I showed you before for reactive programming. Basically, all we do in reactive system is we move from synchronous pull-based architectures to asynchronous push-based architectures. Let me guide you through this by the history of microservices, so to say. Yeah? At least the history of microservices I was in. Yeah. So when we started with microservices, I would say 2010, something like this, when huge enterprises or when most companies actually in Vienna or Central Europe picked up the architectural style of microservices, we had this idea, we have a web application. This web application is talking to a microservice. This microservice A is talking to a microservice B. This microservice B is talking to a microservice C. Microservice C at some point in time responds to microservice B and so on and so forth. And as we have seen before, when microservice C has high latency, for example, that's a bottleneck for the whole system because we do not support back pressure. We have this first generation of microservices. This was very synchronous without back pressure support, right? And then people started to realize this, and said, okay, we need to solve this issue. So we need to isolate the bottleneck. And we did this by introducing queues in many situations. So we decoupled the direct communication between the microservices by introducing a queue. So if microservice B talks to the high latency microservice C, it just sends a message to the queue and it's more or less done then, right? And whenever microservice C is finished, it returns those messages to the queue and microservice B can consume it again. So that's the second generation of microservices where we did already partial asynchronous communication with queues. We used a lot of tools like ActiveMQ, RabbitMQ, or Apache Qubit. Yeah? And then we started to actually scale out those systems because we realized, okay, with queues, we have location transparency. We can easily scale out systems. For example, this high latency system. And we started to put queues in between everywhere, right? Because we realized queues bring a lot of advantage when we kind of need resilience within our system. And once we were there, where actually all microservices were just communicating via queues anymore, we said, okay, let's rethink this a little bit maybe, yeah? Let's start with the web application again. The web application usually talks to kind of backend for frontend or kind of any other microservice, right? And this microservice then took the message and wrote it to a stream. And whoever was interested in this message, let's assume a new payment, a new transaction was triggered, right? Web application triggers a new transaction, sends it to the microservice, to the backend for frontend, and this backend for frontend forwards this new transaction to the stream. Then maybe we have a microservice A, which checks for money laundering. And he says, okay, cool. Payment event, new transaction event, that's interesting for me. I subscribe to this. Let's check if it's relevant for money laundering. No, everything looks fine. Let's write back, okay, this payment should be performed. So perform payment event or something like this. We have a second microservice, the payment gateway, picks up the payment event from the stream, says, okay, let's perform the payment. Once the payment is performed, we write back to the stream, okay, payment performed event. Last microservice, maybe kind of a notification microservice, sends out an email if the payment was successfully done. Takes the previous event, subscribe to it, writes back, okay, payment successfully done, email sent out, web application just shows, okay, cool, the payment was done. So this was kind of the third generation of microservices we saw, fully asynchronous and stream-centric. And we usually used tools like Apache Kafka or Apache Pulsar for this. And what we realized when we built those systems is that events can act as the system state. In this very simple example of a stream of transaction, let's go through this again. Max sends David 100 euros. Max sends Maria 70 euros. David sends Maria 25 euros. These events actually represent the state of our application, because by just having those events, we could easily say, okay, cool. This is currently the balance of all our system users. David has 75 euros because he got 100 euros from Max and he sent 25 euros to Maria. Max is minus 170 euros because he sent 100 to David and sent 100 to Maria. And Maria has 95 euros because she got 25 from David and got 70 from Max, right? And this is what we typically call event sourcing, or what we typically call event sourcing. And this idea of event sourcing is not new at all. It just allows us, or reactive systems with a very event-centric approach allow us to do this very easily. And if you think about it, this is how banks, for example, worked since ever. If you go to a bank and say, hey, sorry, something is wrong with my bank account. I should have 100 euros on my bank account, but I just only have 75 euros on my bank account, right? If they just tell you, let me check the table. In the table, there's 75, yeah, then they would have a problem because nobody would believe them. Because what they basically do is they take all the transactions, sum them up, and ultimately end up in a balance. And this is this 100% reliability which comes with event sourcing. And by taking this idea further, we saw a new generation of microservices where we said, okay, we maybe don't even want to have the persistence in the microservices anymore. We want to centralize the persistence on the stream. So we move the persistence from the right-hand side to the left-hand side. Usually then don't call it stream anymore. We call it event store. And what we then, of course, also can do is we can move from microservices to the world of functions as a service, because those functions, those services are actually stateless. So that's why function as a service makes a lot of sense here. And that's the so-called fourth generation of microservices, event sourced with function as a service. We use tools like Event Store, or still in some circumstances Apache Kafka for this. But that's not the important thing here. The important thing, doesn't matter if you go with a central event store or just a central stream, is that we move fully to streaming. Beside one small thing which doesn't stream yet, the connection between the web application and the microservice. Because here we ultimately, or we actually had HTTP, or we still have HTTP. And we all know HTTP is pull-based, request response. I ask you something, you get me the response. So we have a nearly end-to-end reactive system, but not on the UI side. There we needed to do polling or other stuff, right? Or we started to work with WebSockets. We built our own WebSocket connections, which was a nightmare. And this is where ultimately GraphQL starts to shine. Because I have the feeling GraphQL has a lot of momentum right now, and people use it and I like that they use it. And they say, hey, we use it because we can have consumer-driven APIs. That's a cool feature of GraphQL. You can build very dynamic APIs. The client actually says, hey, I need this or this or this data, right? But that's not really the differentiator for me, because we build it backend for frontends for exactly this purpose, to build APIs that fit the consumer best, right? And then you say, we have native schema support. That's also great. Yeah, don't get me wrong. I like custom-driven APIs in GraphQL a lot, and I like native schema support a lot. But again, native schema support, this is what we had with Swagger and OpenAPI and REST already, right? So it's again not a big differentiator. And this is where I kind of see the problem, or kind of a problem, that people use GraphQL as super dynamic REST. But then you don't utilize GraphQL for what it really is or for what it really brings, because it brings end-to-end streaming support. Because we all know GraphQL has these three options. You can mutate data, so you can update it. You can query data, which kind of means that you fetch data once, so you pull it in a pull-based manner, or you can subscribe to data, which means that you subscribe once, and whenever the data changes, whenever new data records arrive, you will get those data records. So in this simple example of a to-do list, you could query the to-dos, or you could easily subscribe to the to-dos, and whenever a new to-do arrives, this subscription will trigger, and you will see the new to-dos on your UI. And that's fantastic. That's a fantastic feature again. Because by going into this direction, we ultimately have a very, very useful tool to get this red box here done by replacing a classical backend for frontend with a GraphQL server. And now you see it. Now you see the beauty. We moved from a fully pull-based architecture to a fully push-based architecture. Okay, sounds great, maybe, but why is this useful? Let me give you two examples from real-world projects where this was applied or where this is applied. Insurance portal. So due to COVID, the way how insurance companies work changed a lot, right? So insurance business is mainly, I talk to you, you talk to me, we find the best insurance for you. You come to us in the branch. And I try, okay, you have a new car, I give you the best insurance for it, right? And COVID made this a little bit, yeah, I would say, not so easy possible. And the personal interaction between an insurance agent and the customer is very important, it turned out, right? So there were ways, how can we improve this interaction again? Or there were ways to think, how can we improve this interaction again? So typically, you don't need to be an insurance expert. I tried to make this example now in a way that everybody understands it. So an insurance agent is sitting in its branch, and you come to him and say, hey, I have a new car, this brand, this building year, this car model. So let's assume we built this application in a reactive manner. Of course, we could build it in every other way, but let's assume we build it in a reactive manner. Let's assume we have here a GraphQL server, so whenever the insurance agent changes the car brand, this will automatically trigger an event. GraphQL would provide it then to the event, store this event, and some lambdas would, for example, react to this event and would say, okay, cool, the car brand was changed. I give you these possibilities for the build year selection and for the car model selection. And now the beauty comes in place. If you would now imagine it would be perfectly, especially in COVID situation, when the customer can follow, like you would do on the branch, the interaction of the insurance agent. So we just call in with a webcam maybe enabled and say, hey, here's the link, please follow what I'm doing. Just tell me what car you have and I will type it in and you see it directly on your screen, on your mobile client, on your iPad, on your laptop, whatever it is, right? And we do so by just introducing a second GraphQL server and building the second UI again in a reactive manner. So whenever the insurance agent changes something on his side, it will automatically push to the system, and the GraphQL server from the customer will subscribe to the event store, and whenever, for example, the car brand is changed, it will be automatically changed on the side of the customer. And suddenly we can just start interacting with each other, because suddenly the customer needs to say, okay, this information is correct. If this information is accepted, then we move on to the second step. And we need to select the coverage. And here we have 70% coverage for 200 euros. Maybe we want more. The customer says via webcam, hey, 70% is a little bit less. How much would it cost if we move it to 100%? Well, then the insurance agent just moves the slider on the same time. The customer will get directly update on his UI and will be able to sign the deal directly. Let's sign it digital. Let's close it directly in this kind of flow, right? And this is where we realized that customers expect real-time synchronization between channels in many situations these days. Yeah? And this reactive architectures provide us this real-time integration between different systems for free. We don't need to pull for data. We don't need to pull, hey, is there new data? We get it pushed, right? And whenever somebody changes this data within milliseconds, yeah, the other channels are updated, and that's a fantastic feature, because it would be very complex to implement in a non-reactive manner. If we take a look at the second example, mobile banking. Mobile banking is a domain where we are strongly working in. We're doing lots in financial services, and we did a research a few years ago, a bank did a research a few years ago we worked with. And what it actually found out, that mobile banking usage is kind of interesting. They were re-implementing the mobile applications, and they found out that 93% of all the traffic, all the usage on the mobile phone for mobile banking is to show balances and transaction. 93% of all the usage, what people actually do with the mobile banking app, is just showing the current balance and showing the last transactions. The other 3% is initiating new payments, right? So 96% is initiating a new payment and showing the last balance and showing the last transactions. Any other stuff are just 4%. This is just used by 4% of the time by the users. So the features where we invest, I would say, years into, is just 4% of what we actually need on the mobile banking application, right? And that's interesting from one perspective, because 93% of the users always expect to be able to see the current transactions and the current balance. And if we sync this architecture again now in a reactive way, where we say, okay, we have our web banking, we have our GraphQL, we have our event store, we have our microservices, then in reactive systems, we can easily introduce something which we tend to call a projection. And a projection is nothing else than a read model for specific clients. So in this situation, we will build up a projection for our web banking. So we would start to subscribe to events on the event store. And with these events, we would hydrate our projection, which basically means that we would fill our hydration with data. And then in the next step, the web banking only reads from this projection. Right? So this is the basic idea of a projection. And if we now introduce a second channel, one tool to do is Hasura, which is a GraphQL server with a projection out of the box with it. Yeah. And if we now move forward and introduce a second channel, let's assume we have mobile banking here, a mobile client, yeah, and we introduce a second projection just for this mobile client. Yeah. Then we have two GraphQL servers with two projections. Yeah. Then we have very strong decoupling of the system. And what's really interesting now is, what I really love to show is that we could fully burn the backend, and 93% of the use cases which people are actually doing with our application would still work. Because 90% of the use cases to show last balances and to show last transactions. And you would say now, okay, we could also achieve this with read models or classical caches. Yeah, you could, but then you run into the two problems of software engineering, naming things, cache invalidation, and off-by-one errors, right? Because we don't have the problem of cache invalidation here anymore. In reactive systems, you never have the problem of cache invalidation, because cache invalidation is a synchronous problem. because you always need to pull and ask, okay, do I need to pull data now again, or should I keep the old one? In push the system, you always get the events if data is changed. So cache invalidation is never a problem. And this idea of projections, which we get kind of for free in reactive architectures, of course, has an amazing impact on the resilience of our system. And this brings us directly back to the reactive manifesto. So to close this up, yeah, this stuff is cool, of course, yeah. But please think twice and ensure that reactive architectures really fit your problem at hand. Because as all architectural styles, they buy you options, right? And reactive architectures buys you mainly resilience, real-time capabilities, elasticity, and extendability. And the important thing, and that's true not only for reactive systems, that's true for microservices, that's true for reactive systems, that's true for event-based systems, that's true for function as a service architectures. They buy you options. That's the most important verb here. They buy you those options. You don't get them for free, right? And in software engineering and software architectures, we always pay with one currency, and this currency is complexity. So think twice if you really need these options, if you really want to buy these options by complexity. So maybe start small and shift to reactive systems once needed. Hope this was useful. Thanks a lot.
Okay, thank you, David. That was super interesting. So I enjoyed it very much. Let's go into the Q&A session. And let me see if there are any questions. Okay, there are a couple of ones.
Cool.
Yeah, maybe let's start with this one from Katrin. She's asking, how do security measures change when you use reactive applications instead of microservices?
Security measures in forms of how to ensure that the data is not stolen, that data is not leaked, right? I guess, I mean, you're mainly pointing to this concept of distributed data by, for example, introducing projections. Well, this is not such a big shift from my perspective, because also microservices were built in a way that localizes data to the microservice logic. So we also have distributed data there. The only big shift is in general the integration between the systems, yeah, because now you don't send them synchronously anymore, you send them via events. And for example, somebody could steal those events. From this perspective, it is important, for example, also secure the events, to encrypt the events, to have kind of central key storage for those keys, to keep it in a secure way. Yeah. I hope this answers the question, because security is, of course, a huge context, a huge topic in this context. But in general, I don't see such a huge impact on reactive systems in comparison to classical microservices on the security aspect at all, because it's still a distributed system, and the hugest impact on security was for me that we started to build distributed systems in comparison to classical monoliths. Yeah.
Okay. Next question. Let me see what we take. Okay. When putting a stream between microservice A and microservice B, in whose responsibility is the queue from message format, but also operated point of view?
Yeah, that's a good question. That's a question many enterprises are asking these days. We have a lot of discussions exactly on those things. Who owns the data streams? Who owns the topics? Who owns the message format? Do we have a schema registry in the middle to ensure that only messages are allowed to be sent, which fulfill specific criteria? Who owns the versioning of all these message formats? So just adding new questions. But the main distinction you need to do is if you go with a centric, for example, Kafka instance, or if you go with federated event stream architectures, where you still have kind of a central event stream, but the event streams are, for example, owned by the services which consume them, right? So you have kind of delocalized them, right? But there are also approaches where I say you have a central one with a central schema registration, and then it's usually an integration topic. Then usually you have an integration task force which takes care that those streams are designed in a way so that they can be reused. But in general, I'm not a big fan to put one big Kafka into one big company, because you also wouldn't put one big database in the center of this company for integrating all the systems. I'm thinking of still event-centric or stream-centric, but with a federated string composition approach. Yeah. So this goes a little bit into string composition. We can talk about it afterwards, but basically that's the answer. Yeah, by not having a central event stream, but having distributed event streams so that we can easily manage them independently. Yeah.
There is a related question also, I would say. So there is a question about, should there be one stream for all message types or one stream per message type?
Well, it depends what is a stream, right? A stream is usually a topic in most stream implementation or in most event stream implementations. So of course there should be a separate topic, and how you cut those topics is like it's in event-based systems, but this has not even to do with reactive systems so much. In event-based systems, we have the same difficulty which we have in microservice architectures: how to cut the services, how to find the best messages, right? And this can be, for example, that you send messages based on entities, or that you send them based on events, on business events, or that you send them based on technical events. But ultimately, you again need to understand the domain very well. Yeah, so there is not the perfect answer how to cut topics and how to structure events in the best way. Yeah, as you do when you need to cut your microservice architecture in a good way, you really need to deeply understand the business to come up with this. But yeah, of course, there's not a central stream for all events. There are fine-grained topics for each kind of event which you want to send over the stream.
Okay, then let's see, what is the next question from Rob? Can you use GraphQL and Redux together?
That's a good question, basically, because if you think about the idea of reactive systems, then Redux is in reactive implementation, right? Because Redux actually follows the reactive idea very well, because you subscribe to the store, and whenever the store changes, you will automatically update your UI. Yeah? And where I see GraphQL is that we move actually the Redux store to the transport layer. So we move the Redux store back to the backend for frontend with a GraphQL server, because we don't need the separation of building a reactive store on the UI anymore, because suddenly our backend acts in a reactive way. So we can easily subscribe to the backend and mutate the backend as we would do with a Redux store. Yeah. So it depends, as always. Yeah, you could build systems still in a way that you have GraphQL and on top build a Redux store mainly for offline first capabilities and things like this. But in general, I see that in some situations, or in many situations, the Redux store got kind of obsolete, because the backend now provides you these functionalities which you would have needed to implement on the client with the Redux store, because what a Redux store basically does, it translates side events to reactive store, right? So HTTP requests synchronous to a reactive store, and it's not needed if you go with GraphQL anymore.
So you could actually replace the Redux part with GraphQL, actually.
Exactly. You know, a Redux store was localized a reactive system for the UI. But if your whole architecture is suddenly reactive, you don't need to build a reactive component on your UI, because your whole system acts in the same way, right? You start to subscribe and you start to mutate. I would say if you use GraphQL, you only see the beauty of GraphQL by just doing subscriptions and mutations, right? Because then you start to subscribe, somebody mutates, and everybody gets updated, right? So the need of Redux is not that needed anymore, because you don't have this break where you have to communicate, or where you have to translate between synchronous and asynchronous communication. Hope this makes kind of sense, but we can for sure continue the discussion afterwards. Yeah? Okay. Very interesting question.
Two questions left, tricky ones. So first one is how scalable is the reactive approach really What's the limitations and risk? I think you did have a touch on that in the presentation as well, also about risks. But maybe you want to.
Sure. I mean, the scalability is one of the main goals why we start to build reactive systems. Yeah, in the two examples I showed mainly the resilience part, where I said, okay, you can burn the whole backend from the bank and you would still be able to see the transactions, and I showed the real-time capabilities. But a little bit earlier I showed location transparency, where we can easily scale out systems, and especially if we move to an event-centric or even event-sourced, event store approach, we can scale out the functions because they are stateless endlessly. Yeah. So the difficulty with scaling is usually statefulness and synchronous communication between services, and we kind of can solve both issues with reactive systems. So from this perspective, it brings a lot of benefits. You can utilize reactive systems in a way that I would even assume it allows us to build the most scalable systems. If scaling is our main goal, yeah, then reactive systems definitely have the strengths. The risk and the downsides are, of course, complexity. Yeah, if you really ever worked in a fully reactive system, it's hard to debug, for example. It's hard to trace because everything is reacting. You put somewhere here a number and suddenly all the other systems maybe change, right? That's the beauty of it on the one hand. On the other hand, it makes it complex to understand and complex to debug, for example. Mm-hmm. Basically, that's the point, yeah.
Okay, and then the last question, a tricky one. Monolith versus reactive app development time for mid-sized applications. Yeah, depends on the application, right?
So how long it takes to implement those?
I think this was the question. Yeah.
Well, as I said, if you don't need any options of reactive systems, don't go for them, yeah, because you pay by complexity, and complexity costs development velocity, right? Mm-hmm. But that's true for all architectures. If you don't need the options, microservices provide you in independent deployments, I don't know, scalability, and so on and so forth. Don't go with microservices, stay with monoliths, because monoliths are for sure the simplest and easiest way to build applications, but they have the limitations, right? Scalability, you can usually only scale up monoliths and not scale them out. So sure, if you don't need all of this, that's perfectly fine. Monoliths are for sure the best choice, and we always say this, yeah. As I said, they buy you options. If you don't need these options, don't go for the complexity. You need to be able to buy them, right? So yeah, I would say monoliths are still the fastest way to build applications, but of course, yeah, we all know the downsides, I guess. Yeah.
Okay, so this was the last question. David, thank you so much for joining us today. It was super interesting to learn about GraphQL and reactive architectures. I hope to have you in the future again as a speaker. I know that you are also talking on micro frontends, so looking forward to that one as well.
One last announcement, if I'm allowed to do.
Of course.
As I said, we do a lot in this reactive architecture stuff, and we have a high focus on this right now, and together with a couple of other companies, we were happy to announce a really free Apache Kafka training. So I'm happy to avert this here now. My screen is not visible anymore. I will just share it because it's a perfect opportunity for those who are maybe interested in this topic and would like to learn more about this. So we really do it just for the community. It's a community training. It takes, I think, 6 hours, and we will touch points most of the concept. And I know I just kind of explained them on a very abstract level. And maybe some of you said, I would like to see code. I would like to do this. Yeah, that's a perfect opportunity to do so. So feel free to register. Happy to see you there. Thanks for the invitation. I'm happy to come back. I'm happy to talk about microservices as usual. Yeah, it was a pleasure. Hope to see you all at some point in time again, face to face. And this would be my wish at the end. Yeah.
Thank you, David. So bye-bye. See you later and see you in the future. So we are moving on with a very short break, just a couple of minutes, so around 5 minutes, and then we will have our next talk, very interesting as well, with Rowdy, and he will talk about native script. So stay tuned, grab another coffee, and see you in 5 minutes again.
Why should your business go hybrid? When I'm in a race, I should be focused on taking a corner, But what if I had to run around, worried about engine temperatures, thinking about changing tyres? That's how some businesses manage their clouds. But with a hybrid cloud approach with IBM, you'll have the expertise of a team designing best-in-car strategies for your business, the same way a pit crew makes this car hum. So you can focus on, you know, winning.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies...
Okay, welcome back again. I hope it was enough time to grab a coffee. I'm here with Rowdy. Rowdy, how are you?
Hi, good afternoon. Lonely, missing people around me, but Well, it's the next best thing, right, to do this.
Yeah, at least we can stay this three in touch, right? Better than nothing.
Definitely.
Rowdy, tell us, where are you joining us from?
I'm from the city of cheese in the Netherlands, Gouda. And it's quite a lovely day outside here, so that's good.
Is it called like the cheese? Gouda, is this the same name?
Yeah, but we call it Gouda, but for many people that's not the way to pronounce it easily, so Gouda, say Gouda.
Okay, perfect, so learn something today. Tell us, what will we learn from you from your session?
Well, if you have web skills like CSS, HTML, and JavaScript, you can also use them to create native mobile apps. And I'm going to show you how to do that and actually how easy it is.
That sounds very interesting. So looking forward to that. Rowdy, the stage is yours.
Thank you. First, let me set a picture here with something I call the web developer mood coaster. So this is you probably, if you are a web developer, in your natural habitat.
Everything's gonna be all right now. I got this. You wanted to know who I am?
What the hell are you talking about?
You'll see!
So you're confident, right? Nothing can happen. I know everything. Good. Because you know HTML, you know CSS, you know JavaScript, maybe SAS and NPM, you know it, no problem. But then let's see if you can work on native iOS or Android. Well, my first experience was like this. Yeah, what did I start there? App stores, provisioning files. I need to know Java or Kotlin or Objective-C or Swift for iOS. Oh man, that's hard. That's not what I know. But let me tell you, you can go with NativeScript and your experience will probably something like this. Oh yeah, you got the power, you know how to handle yourself. With the knowledge you have from the web, you can conquer native as well. Okay, you still have to deal with app stores, provisioning files, but in the end, it's not that hard, actually. You have to learn a little bit of NativeScript, but it's very intuitive to use it, so that's fine. And you can use your skills. As I said, HTML, CSS, and JavaScript. You can use SAS and NPM as well. So I hope after this talk, you as a web developer are going to love NativeScript. About love, who is this guy in front of the camera, actually? Well, my name is Rowdy. You can follow me on Twitter on @RowdyRabouw. As I said, I'm from Gouda. I'm a freelance web and app developer and also employed by the largest Dutch insurance company called Nationale-Nederlanden. And I'm the lead developer there of the pension app we created. And also I'm a developer expert for NativeScript. And you might have guessed already, I love superhero movies. Usually my girlfriend joins me. So lately she said, well, you know, you're looking more and more like Thor every day. And I was like, well, I like that. Until I realized she said it to me after the Endgame movie. So Corona, right? Corona kilos there. Okay, all jokes aside, let's go to the mobile app framework decision guide, because NativeScript is not the only solution. It might be right for you, it might be not. So let's see what options we have. First question, do you have too much money and time. If you're a big company, you don't care that much, maybe you could go for native iOS and Android. You will have to build it twice because it's two different platforms. And as mentioned before, you need to know Java or Kotlin for Android and Objective-C or Swift for iOS. If you don't have too much money and time, maybe you want to consider if you want to use web technologies. If it's not that important to you, you could go using Xamarin from Microsoft. You have to write it in .NET or C#. It cross-compiles, and you really need to create your own bindings to access native APIs to get control of Bluetooth and stuff like that. Okay. You do want to go with web stuff. Do you need a native user interface and performance? It might be important, it might be not. If it's not that important, you might also think about using Apache Cordova /PhoneCap /Capacitator, how it's called now, with Ionic. Your app will run in a web view inside an app. You have a DOM to manipulate, like on the web, and all the components are styled like they look native, but they're not really native. Okay, do you want to use modern JavaScript? Maybe you're stuck in the past and you like that. You could maybe choose for Titanium. It is a bit outdated, but still it could be relevant for you to use. It doesn't have new support for ES 6 or 2015 and above. You can't use NPM, and they have a pretty older framework for creating pages. So you have to keep that in mind. If you want the latest and greatest, do you know and like Dart? If you do, you could choose for Flutter from Google. This will cross-compile your application from Dart to iOS and Android. Maybe you know and like React. If you do, you could choose for React Native. You use React, but in this case, you still need to build your own bridge to access native APIs, as mentioned, Bluetooth or the accelerometer or things like that, or the camera. But keep that React in mind. Hold my beer. Keep it in mind for later. If you don't know React, Flutter, or don't know React or Dart or any of that stuff, and you still want to do web development on native apps, you have to choose for this superhero native script. It's very versatile, and let me show you why. First of all, what is it? Well, it's an open source framework. So you can contribute and make your own plugins for it and share it with the community. And you will, in the end up with truly native mobile apps. So you're going to use truly native components. A button is a real native button, for instance. It's built with JavaScript, a markup language that can be either XML or HTML, and CSS for the styling. You can even run native code inside of your JavaScript if you want in there, and I'm going to show an example of that. It's cross-platform. You have one code base for iOS and Android, but you're still able to differentiate between them if you want to. It was originally developed by a big software company called Progress, and it's now in the hands of a group of people that run it in open source. If you want to learn more about NativeScript, there are extensive documents as well. There's a free book available. And my friend Alex has a great learning platform called Native Scripting, where he has free and paid courses on different variations of NativeScript. So if you want to know more, check that out as well. And this is incredible thing for me. We have the playground, and the playground makes it possible for you to go online in a browser, create some stuff, and sync it to your device. And it's real time. So if you, as you say here, push it, you get feedback, and it will sync across the connected devices. You have to install 2 apps for that, and then you can try it out. And it's also a good way to tinker a little bit with it if you're new to it. Check that out as well. Okay, let's go to the building blocks. First up, markup. And it's truly like on the web. You will see that it follows the same guidelines. Look at this example, for instance. First, we have an action bar. Let's say the bar on top of the app. And we give it a title of native elements here. And beneath that, we define the actual contents of the page. You always need to have a layout. In this case, I use a stack layout. I will explain later on, but I use a stack layout to group everything together. Think of it as a div, for instance. And as you can see within that, I have a button, a switch, a segmented bar, a progress bar, a slider, and a date picker. And in the end, if I run this, it looks like this. If the video starts, yes, there it goes. On the right-hand side, you see iOS, and on the left-hand side, you have Android. And I didn't have to do anything special, just define a button or a progress bar or whatever, and it is immediately run in its native components. So you can see a clear difference between iOS and Android. And that's fine because people are used to that. A text field is, for us in the pension app, a very heavily used element because you want to have people to enter data. Well, just like on the web, you can have a text field, put some text already in there, or have a placeholder we call on the web. We call it here a hint that will be inside of the text field. But it also has other very nice attributes like auto capitalization type. So you can make sure that all characters are in uppercase or only sentences or words if you want that in your app. But more importantly, you can also set it to none. And I like that very much, for instance, on an input for an email address. I hate it when the first letter of my email address is uppercase. And another one, autocorrect. If somebody is entering his name, for instance, in a field, you might want to turn autocorrect off because it can get really nasty. And one of the things that's also really useful, and that is more or less the same like on the web, you have the ability to select input types, in this case, keyboard types. So, for instance, number, date, time, phone, email, and URL. And if you do that, it will look like this on the left-hand side on Android and the right-hand side on iOS. And you can see, again, some little differences between both platforms. But again, that's fine. Users are used to that. And there are many, many more attributes, text alignment, for instance, visibility, width, or max length, or whatever. All of the components that are there, you can set things through these attributes. Okay, let's have a look at layouts now. I mentioned stack layout already, and stack layout is nothing more than just putting things underneath each other. Like on the web, you have a div, another div, and another div, and another div. You can also set the orientation to horizontal on the stack layout, and then it will be next to each other. Like on the web, also you can set an absolute layout with positioning for top, left, right, or bottom. And one that's very commonly used is a dock layout, where you have, for instance, a static sized bar above and below, and the center is dynamic depending on the size of your app. There are more. We also have the grid layout, the wrap layout the grid layout I'll explain later a bit. The wrap layout just takes the space it has, and if it's too big, this just goes back to the next line. again, you can set the orientation here as well. And adopted from the web is the Flexbox layout. So you can use your Flexbox knowledge from the web, creating a layout in a native app as well. So just let's have a look at the dock layout in this case. What I did here is that I set the height of the dock layout to 100%, so the whole device height. The last child, I set stretch to true there, so it will take up all the available space. And that the last child is not the last one that you see on the page, but it's the last one that's in the dock layout. So in this case, the label with text 4 in it, which is on the left. So the green part takes all the available space. And the other ones, 1 and 2 and 3, I've given them a fixed height, and 3 I've given them the fixed width. As mentioned, the grid layout, it's more or less like a table, not a CSS grid we know on the web, but more like a table. So you can set rows, calls, and you can span over calls and span over rows as well. If you look at the rows and columns, you see, for instance, 100, that's 100 pixels. It's device independent pixels, not real CSX pixels. It depends on your device. You can set it at auto, and auto means just use what you need. And the asterisk means use any available leftover space. Okay, one part, the HTML or the markup. Let's go to making it beautiful with CSS. But from CSS, a large subset of the CSS properties we know on the web is supported by NativeScript. I haven't really come across CSS properties I wanted to use and couldn't. As mentioned, there are device-independent pixels, so not CSS pixels. For the CSS, you can set it for the complete application, use classes or target buttons directly. You can set it for your whole application. You can say, well, only for this page in my app, I have some separate CSS. But you can also set it inline, just as an attribute there. You can use platform-specific CSS. So if you say, well, on Android, I want this, maybe I want to there have for some reason, have a border, a red border, and on iOS, it should be blue. It's fine. You can set it like that. There are attributes for that to target different platforms. Also, you can use animations, CSS animations. And I have an example in the demo app I'm going to show you later. And you can use SASS if you want to speed up your development process. If you're not that comfortable with CSS, you can also make use of the core themes that are already available. There are, I think, 12 or 13 different themes you can use, and they are created for iOS and Android. If you want to experiment, you can go to the NativeScript Theme Builder. There you have a live view of elements, and you can tinker around with the colors and the text sizes and stuff like that. And afterwards, download that theme and use it in your app. Well, with this knowledge of markup, HTML, and CSS, we can already create something really nice. Because you probably have seen it in different apps. There's something called a tab view. So you can have some buttons. You can switch from one to the other. And it's very easy in NativeScript to create this. I have this tab view. I set it at 100% to have the whole page. And in there, I have 3 stack layouts with 3 items, which I gave a title, and I gave a CSS class. Full means I want to have it fully there, like background size cover, so cover the whole screen, and then the separate CSS classes are just for the background images. So nothing really fancy, but in a few lines of code, I can create this. Again, left is Android, right is iOS, and you can tap through and you see changing the images. Out of the box, nothing particular to do. Okay, we have had HTML, CSS. What about JavaScript? Well, when I started doing this talk, we had 4 fantastic choices. Well, some things have changed. We have now 6 big heroes. So 2 options have arisen. First of all, you can use plain old JavaScript. No problem. You can use TypeScript. You can use Angular. You can use Vue. My friend Igor created NativeScript Vue for this. You can use Svelte or Svelte. I don't know how to pronounce it, but it's there. And David created Svelte Native. And I said, hold my beer. You can even use React inside NativeScript. So if you don't want to do React Native, you can do React NativeScript by Jamie. I know, insane. What's more insane is to use native code inside of your JavaScript. I have an example for you how to do that with Objective-C. Usually when I create a NativeScript app, I use Angular. So I have this directory structure, and that's pretty common. If you know Angular, it's nothing fancy. It's having this setup. I'll go through it a little bit. So I have an HTML file that defines my screen with an action bar that should be hidden in this case because its visibility is collapsed. And I have a stack layout underneath there with a slider in it. I give the action bar a color of white, and I give the stack layout some padding just to don't get it squished to the sides. Then I have a slider component.ts. Here you do your JavaScript stuff to create nice things. What you see here on the screen is just plain boilerplate, nothing spectacular. And also we have a routing module that just said, well, if you come to the slider component here, you need to load this and this and this stuff. And to have it all together, we have a module. Also, straight out of the box, nothing fancy here. So it looks like this. Well, not really useful, but we have a slider on screen. Let's make it a little bit more interesting. As I said, I want to use Objective-C in my code. So what I did here is I added a slider-icon to slider. And that's called an attribute directive. And with this directive, we can change the appearance or behavior of an element. So if I go back to I created a directive file, the slider.directive.ts, where I import directive and element ref from Angular core. I set the selector, and I create a class with a constructor. The fun part is I can now also import is.iOS from NativeScript core. And there's also is.Android. But I want to use is.iOS, if you look later on, to do something different with that slider. So if it is iOS, I grab that slider and I call it UI slider. And the next line is pure Objective-C. I have that UI slider now, and I can say set thumb image for state and use image.png to use that as a thumbnail. Don't have to do anything special. It's directly Objective-C here. I want to use this directive, so I have to import it as well in the module like this and put it in my declarations to be able to use it. And you get something like this. Okay, I cheated a little bit. I did a little bit more than just changing the image. I changed the image to Captain America's shield, but I did a little bit more. What I also did here is I expanded it a little bit and make sure that I had a background with Captain America on it. And I put a flexbox layout around things to center it and make it nice. The Captain, just CSS for it, have a background image, make it cover all, center it, and do not repeat it, and make it, in this case, first an opacity of 0, so don't show it. I center things, I give the slider a width of 80% of the screen, and I give it a background color, the red one, if you saw it, just because I can. Then I import some extra stuff from NativeScript core. So I can manipulate the page, the slider, the stack layout. And also I imported a plugin called NativeScript Audio. I will get back to plugins later, but with NativeScript Audio, you can do things with audio. So I import the TNS player here. And in the component and now, the most important thing is that in the ng on init, I load the Captain MP3 file. So that's the soundtrack you heard. And what I did is if you change the slider, so this is the on slider value change, you get an argument back. And you get the value from 0 to 100. Now, opacity and volume ranges are from 0 to 1, so I just divided by 100. And in this case, I could say, well, if the slider value is above 0, I play the MP3 and set the volume to that slider value. So when we went higher up the slider, the volume became louder as well. And if it's just to the left, then just stop playing. There you go. Well, I said plugins, but first let's talk about packages and libraries. As mentioned, you can use Node Package Manager, probably better known as NPM, and it serves ready-to-use JavaScript modules. There are 100,000 of them. I don't say they're all that useful, but the ones you can find and are useful for you, you can use them in NativeScript. Well, I said here are 650,000 packages. Maybe there are even more now. But you can also use libraries especially for Android or iOS. So from Android Arsenal, written in Java, Kotlin, or Cocoa Pods, written in Objective-C and Swift. So you can benefit from the web plugins, but also from the native libraries. And I want to show you one. One we use in our app, and I use myself a lot as well, is NGX Translate. And that's a perfect library for internationalization. So if you want to create a multilingual app, you can use this internationalization library. You can define translations in different languages in a JSON file, in separate JSON files, and you can switch between them pretty easy. So my recommendation is, even if you only have one language, I wouldn't define all the text inside of my pages in the app, but still use an internationalization library for this. Because then if you want to change something, it's all in one file. And this is an example like we have. This is in Dutch. And if I go to settings, I can switch to English. And see it's settings and info now already, and I go back, all is translated in English with a flip of a switch. So something to keep in mind. This is a little example we did on the buttons. It's called, this is the JSON file. We have a chart with buttons, a button called salary, a button called pensions, and a button called choices. You see the Dutch names for it. And if we switch, here you have the English version. So we maintain two files, two JSON files, and we're really happy. We can offer multilingual. I even tried it once with German, just for the fun of it. So we ran our JSON file through Google Translate. And I think within 10 minutes, we could serve a German version of our app. Not sure if all translations were correct, but it's pretty easy to extend that way. And the way you do it is that you do one-way data binding, in this case in Angular. So that's the brackets around text. We point to the JSON, to the path in the JSON file, and have a pipe there with a display value transformation of translate. And I mentioned plugins. There are many plugins available already. And what are they? Well, the NativeScript core modules provide a lot of things already for you, but some things they don't. They didn't have time for it to build, or didn't see the effort for it, or didn't feel like the effort was enough to have it in the core framework. So other people created plugins. And I must say some plugins are later on integrated in the core modules. Usually they're available for both iOS and Android. They have a JavaScript interface to get connected to the native platform code. And let's try one myself. I created a little one, a very easy one, just to show you what you can do. So I wanted to create a version plugin, just to get the version number of my app. I need to create 4 files for this: a package.json, a version.d.ts, so a definition file, a TypeScript definition file, and a separate file for Android and iOS. In that package.json, I'm just giving it a name, a version, and I set the NativeScript platform for which it can be used. So in this case, 7. I have a definition file that just says, well, I have a class named version, and it has a method called getVersion. That's it. Then in the Android TypeScript file, I import application from NativeScript core. So I get access to application. And I define here the getVersion method again. But the most important thing is, you can see right there, there's Java code here. I get the package manager, I get the package info. But once I got that package info, I can just say, well, return, and I see a typo here, return the package.version name. It's a little bit of figuring out what you need in Android for this. But if you look at the iOS version, you can see you have a file called Android manifest.xml in your project, and you can see it will pick from manifest Android :version code. If you look at iOS, it's much easier. You just have to say, well, go to NS bundle, main bundle, objects for info dictionary key, and get the CF bundle short version string. And that corresponds with the info.plist file, which has a key with the same name and a string with the text you want to show. And if you look in the app, it will show like this in a second. If you publish it to NPM, you can easily install it like NS plugin app NativeScript version. I did it locally. It's not on NPM, so I just install it locally with a / in front of it. Then, if I want to use it, I can use it on any page I want. I only have to import version from NativeScript version and create a new one, a new instance of it, and call getVersion. And it looks like this. If I start the app, here you see I have 1.0 demo. Also, you can now see that I have a CSS animation in there. Let me start it a little bit again. CSS animation of the light bulb, and also I have a gradient, a CSS gradient. So that's out of the box available for you. well, if you don't want to build your own plugins or don't know how, you can go to the NativeScript marketplace and they have a lot of plugins available for you. Also, templates are available for you if you want to start quickly. Well, now scary time for me. I'm going to do a live demo with an app I created. Let's see how that goes. So I'm going to try to mirror my phone. So far, so good. Let's put it here. Okay. And this app is called NativeScript Bulb, and you can probably guess it. It has to do with a light bulb. So if I have the app here as well. So if I hit the light bulb, I get this. So I have the NativeScript bulb, and I have a bulb here. It's just a regular one I bought at the store, the Action. It's probably somewhere in other place in Europe as well, €5 or something, but it has Bluetooth. So let's see what we can do. So first of all, I put it on, bright light. Let me put my other light out, and I hit connect. And it will create a Bluetooth connection to it. And on connect, I said, well, just set it to black. So essentially turn it off. I now have this color wheel on top. So if I hit, for instance, on top the green, I put a little bit to my face. You can see it's a light green. Maybe I can get it a little bit darker. You can also, I see that I translucent because of a green screen behind me. So let's take another color. Maybe this is better, red or blue or a bit of orange. So I can just hit the color wheel and that will send a command to this bulb by Bluetooth. But what if we can just say what color we want? So let's use this. Magenta. There we go. I now use NativeScript speech recognition. Yellow. There we go. Blue. And then it's blue. Red. Yeah, now it gives an array. It's not that bright because it just have an array of names that it can recognize and set a color to it. Bluetooth, in this case, uses the hex colors. But if I hit the color wheel, I get RGB colors. So I have to have a little, in the code, there's a little utility to set that from RGB to hex. But what about using an accelerometer in your app? So when I do that and I move my phone, you can see it will change color. There's an X, a Y, and a Z axis in your phone. X is like left to right, I is up and down, and Z is like tilting. So what I did is the X is now the R, the Y is the G, and the Z is the B. So red, green, blue. Those colors go from 0 to 255, but the accelerometer goes from -1 to +1. So I had to create a little calculation there to get it right. I'm not sure what the use case is of it, but you can have a little bit of fun with your phone on a disco, or I don't know, on a party. Let me stop it for now. Okay. So these are a few examples of how you can use NativeScript to do something nice with a light bulb. I'm going to put it out now and switch to that one, because we're almost there. And if you want to see more plugins, my friend Eddie has created, I think, about 30 plugins now, from all kinds of stuff. Well, 33 here you can see, from mapping, Firebase, augmented reality, speech recognition, drawing in on your screen and stuff like that. So please check that out. The apps are also in the App Store, so you don't have to run the code in your own on your own, but you can just install the app immediately and see what you can do with it. It's very powerful. And with that, I would say thank you. And if you want to see more, if you want to look into into these slides and also the demo code, you can go to rowdy.codes/WAD. We are developers, right? WAD, and there you get you can download the slides and have the link to the GitHub repository. And I'm imagining now everybody's ecstatic and cheering me on. So
well, we can't stop giving standing ovations, Rowdy. So
I can
really
see
cool. We really had a lot of fun here in the studio. Super interesting to see how this whole thing develops. I remember 10 years ago when I was in my first startup. Then back then we didn't have time and we didn't have money, and we needed to do some mobile applications. And because of the lack of time and money, we basically did a web page and used it as a web view to have quickly some native apps in the store. It was kind of working, but as soon as we collected some money, we switched immediately to native applications. So now it's interesting to see, not just with NativeScript, but also like with the other possibilities, how this kind of moves back again. So super interesting. So thanks for sharing all of these things. We have quite a lot of questions. I would start with the first one, which is there a way to use device features, geo stuff, gyroscope, also to collect data from devices like you can do with a native app? I mean, you showed the accelerator on the with the light bulb and so on. So maybe let's turn the question around. What are the limitations? So what is there anything you don't get from the device?
Well, if you if there's a plugin available, or you can write your own code, you can get access to anything a native app can as well. So it says here geo stuff, for instance, geolocation. Yes, of course you can get that. There are a lot of plugins out there already that do a lot. I don't think there are really limitations. The beauty of, in this case, NativeScript is also if there's a new device out there, or a new version of iOS, for instance, you can immediately change your code to make use of that. You don't have to wait for some party to make it available to you. You can make use of it directly.
Mm-hmm. Yeah. So basically, as you said, with the plugins, as far as I understand, it basically is native code that you actually kind of use then and call with your NativeScript application, right?
Yeah, if you're not a plugin writer yourself, you never have to touch native code. If there's a plugin that does things for you that you want, you can use it just as JavaScript. You don't have to write any native code yourself.
Yeah, that's super cool. Okay, then the next question, maybe also easy to answer. Push notifications. I would say like the same way you can use it. Is it possible? Yes. Yeah,
it's possible, but that's just like native. It's sometimes a hassle to get it working, especially with Apple. I've done it in the past. Another thing, what you could do, which I like as well, that there's a plugin that my friend Eddie made, is you can also use local notifications. So if you're for instance, another friend of mine has an app for making appointments at the hairdresser. Very important nowadays. It will give you also a local push notification, for instance, an hour before you have to go to the hairdresser. So it's not only your calendar that's giving you a signal, it's also a push notification. But yes, to say the traditional push notifications are available as well.
Okay, perfect. Then I don't want to start a flame war, but the next question is what's more future-proof, progressive web apps or native script?
Let's say progressive web apps versus native apps, just in general. I do love progressive web apps, definitely. I create them as well. I do a talk about them as well. The only thing is that a lot of stuff you want to do, or you would like to do with the PWA, is plainly not available on iOS. Apple holds back on certain stuff, so you cannot do everything you can do on Android, for instance. So if you want to use capabilities of your phone, I would say use a native app with NativeScript or any other platform. But if you want to give users a good experience, like caching data, giving them a fast website, giving them fast access to your website through a home screen button, for instance, use PWA. PWA has come far, but it's unfortunately not there yet.
Okay. Next question is, can you tell us some examples of popular native script apps, or apps that are made with native script?
The ones I know are maybe not as well known to the audience, but for instance, we have a Dutch banking that uses a native script app. So that needs to be secure, and they created a pretty good one with that. There are also all kinds of apps in the US, for instance, for Secret Santa and stuff like that. On the top of my head, I don't know. I can't say a big brand or something that uses it. I just don't know.
Interesting to know that the bank is using it, because one would think maybe, okay, it's maybe for smaller projects and with the Secret Santa stuff and fun stuff and so on, but seems to be quite mature. Then the next question, you mentioned it in our talk, I think, that you prefer Angular, or that you use Angular. So is there any specific reason why you prefer Angular together with NativeScript? Or?
When I started with NativeScript, we were at version 2.5. We're now at version 7. And in version 2.5, you had 3 flavors. You could use JavaScript, TypeScript, or Angular 2, I think it was at the time. For me, the reason to use Angular was because Angular gives a lot of out of the box for you, like routing and stuff like that. And I didn't want to write it myself in JavaScript. And I just kept using Angular for that.
Okay. And then could you do a short comparison between NativeScript and Ionic?
Yeah, I think the biggest difference is that Ionic, as I tried to explain, it runs in a web view inside of an app shell. So it's not really a native app. It's say a website running locally on your device. While NativeScript, but also Flutter and React Native, really run native UIs and are much faster in processing stuff that way.
Okay. And I mean, that was the last question. Thank you also for the example with the light bulb. It's really amazing. I hope you didn't have some buttons below the screen where you just touch the corresponding colors. Right?
No, definitely not.
When you join us at a physical conference in the future, then we will look at this again, right?
It's 100% real, let's say. Perfect. But I can show you in real life as well, yeah.
Perfect. Looking forward to that. So, Rowdy, that was it. So thank you so much. It was really fun. And I hope that you will join us in the future again, virtual or physical, however. So looking forward to see you again.
Yes. Thank you. And
Thanks,
enjoy all the other days.
Thanks. So we are moving on again with a very short break, 10 minutes. And then we will have another very interesting talk about how to stop choosing JavaScript frameworks and start living. I think that's something that everyone is just waiting for. So see you in 10 minutes again.
business go hybrid? As a coach, my offense is nowhere without a solid line and agile, skilled players. I need the speed of a running back and the security of alignment. A hybrid cloud approach with IBM gets your business both, so you can manage data and apps, whatever plays come your way.
Here, coach.
When security meets agility, you're unstoppable. Bring it in, guys, bring it in, bring it in. 1, 2, 3, hybrid! Why should your business go hybrid? Here's the beauty of a hybrid cloud approach with IBM. Your data, apps, and clouds all work together in concert.
There's never pressure what to do to it. Carolina Diamonds got
so you can make something that's never been heard before. I like that.
I do it for us to be exact. All the applause off of the cause, yeah, off of my
Okay, welcome back everyone. I'm here with Sasha and I'm so much looking forward to this session because it's a topic that I think every developer thinks about it, and we all had our discussions about these kind of things. So Sasha, welcome. Thanks for joining. How are you?
Hi, I'm good, thank you.
Perfect. Where are you joining us from?
I'm joining from Minsk, Belarus.
Beautiful. And tell us briefly, what will we learn or what will you talk about today?
Well, I would say you will learn something about the framework history, about the frameworks and how to choose them.
Perfectly. So I hope that we will have some answers, but even if not, we will definitely have some stuff to discuss.
Sure.
So Sasha, thank you, and the stage is yours.
Enjoy.
Hi, everyone. It's Sasha, and I'm going to talk about the frameworks. So if you're interested in what's going on right now on the screen, what is the picture, you can definitely check it out. I'll share my slides after the talk, so you can go through the links I'll be sharing with you. So let's dive to my talk. Yes, my name is Sasha, and I'm a lead front-end developer from Minsk, Belarus. And I have almost 15 years of experience as a front-end developer because I started to create my first website in high school. So I did a lot of things, including creating markup using tables. So if you know what I mean, I'm sorry for you too. And during my career, I work with different technologies, different frameworks, different even languages, and I work with the main frameworks such as Angular, React, and Vue. So I know what I'm talking about. And actually, I work not just with the front end. I work as a backend developer on Node.js. And beside that, I'm one of the community leaders here in Minsk.
Okay, sorry, I have to interrupt for a minute because we only have a black screen. So we will be back in a couple of seconds, I hope, again.
Okay.
Just a moment. Okay, so we are back, everything resolved, and we will start once again with Sasha. So the stage is yours again.
Okay, so should I start with the beginning or continue, please?
Yes, please, at the beginning, thanks.
Okay. So hi again. I'm Sasha, and let's talk about myself again. I'm a lead front-end developer from Minsk, Belarus. And I have almost 15 years of experience as a front-end developer because I've started to create my first websites in the high school. So if you're like me, created markup with the tables, I know what you feel, bro. And during my career, I worked with different frameworks and technologies and even languages. And of course, I work with React, Angular, and Vue.js. And I'm not just a front-end developer, actually. I'm a full-stack Node.js developer. So yeah, I know how to write code on Node.js as well. And beside that, I'm one of the local community leaders from our front-end communities. Called Minsk CSS and Minsk JS, and I'm one of organizers of two conferences, one here in Minsk, CSS Minsk JS, and another conference, Frontend Conf in Russia. So that was about me, but let's talk about the frameworks. And you may ask me, what would you talk about if you're talking about the frameworks? You will be probably talking about React or Angular or Vue or trying to compare them. Well, why should we talk about the framework at all? Because is there any silver bullet that could help your project you can choose and once and for all? Probably not. There is no silver bullet, no tool that can work for any project, any team in any given time. So what should else I could talk about? I could talk about a lot of things connected with the JavaScript frameworks. I could talk about the platforms, the architectural problems or patterns. I could talk about libraries and tools. Maybe I could tell you some stories, success or unsuccess, or best practices, or real life examples, or I could compare my frameworks, right? But no, that's not what I'm going to talk about. What my talk is going to talk, what I am going to talk about is to try to inspire you to look at frameworks and front-end development in general at a little bit different angle, not as you usually look at it. So when I beginning to think about the topic I'm going to talk, it was always amazed me how we have a big book about JavaScript called Definitive Guide by David Flanagan. And we had another book called JavaScript, The Good Parts, and the comparison between the size of those books are kind of strange, right? And sometimes it's really depressing that the good parts of JavaScript is a really small part of the whole JavaScript. So I ask myself a question. So what is wrong with JavaScript that we are maybe not we all, but a lot of developers are complaining about. And I believe I found five complaints that we usually mention when we're talking about the bad parts of JavaScript. And the first thing is it's simple thing, but very, I would say, harsh thing. And JavaScript, someone may say that JavaScript is a bad language. Well, I'm not agree with that, but JavaScript definitely has some issues, or maybe not issues, but some difficulties. And the main difficulties that usually mentioned is that it doesn't have static types. Well, yes. So what? So what should we do with that? Should we forget the language and start to work on something different? But you know, a lot of languages doesn't have it, and they are good. Beside that, the standard of the JavaScript language is evolving every year, and the JavaScript that is right now in 2021 is definitely not the same that it was in 2015, for example. And those new standards are going to the browsers very quickly, because if you're looking on the implementation in the browsers of the new features, they're quietly fast and in that implementation. So I don't think it's a bad language or something. Beside the JavaScript, if you want to be a front-end developer, you have a lot of options. You have a dozen languages that are transpiled to JavaScript and executed in the browser. So you don't have to write the JavaScript to be a front-end developer, and that's good. Beside that, again, if you're tired or not satisfied with the front-end development, you can go to the back-end development and do things that backend developers do. You know, usually their world is not that fast changing, and you can write same applications from year to year. Or you could go to team leading, and you won't be probably working with the code, you'll be working with people, which in some case might be not the best option for you. The second complaint is there's too many tools to work with as a front-end developers. There is a great article that was written in 2016, but it's still true and still very, well, very explanatory of what's going on in the front-end development community. If you haven't read it, this is the kind of funny dialogue between two developers, one who was up with the new technologies during that time, and there is another one who wasn't, and they're kind of discussing how they create websites in 2016. So check it out, and it's a funny and a little bit sad story, but it's our front-end development world. But on the other hand of having too many tools, that means that we as a developer have a lot of options to work with and have a lot of things that we can choose from. And that's, I believe that's a good thing. That's not bad, because you as a developer can choose whatever tool you like. That would be probably the better fit for your project. And that leads to another claim, is that too many choices. We have 5 libraries that do in one thing, and another 5 libraries that do another thing, and then you're trying to combine them. They might not work. But again, right now in the NPM package repository, we have more than 1.5 million packages. It's a recent number. I took the screenshot yesterday, so we really do have a lot of packages. But again, I don't think that's a bad thing. That means that we have more options to work with, and we're choosing from bigger variety of options. That's good. And that leads to another thing, that our industry is changing very fast. If you're we're looking on the front-end development in the past few years, you'll probably notice that there are different tools are kind of on top of ratings in different years. So sometimes it feels like you're going on vacation for 2 weeks and come back and you have to learn a new stack of technology as a front-end developer. But and if you look at the web itself, it's evolving every year. And during our situation with the corona, the web, again, it's evolving even more. And that's kind of a natural process. You can stop changes. And that is something that we have to work with. And beside that, there are a big amount of different communities around the frameworks, not just Angular, Vue, or React, as you see on the screen. For other frameworks, the situation is the same, and we have leaders in the frameworks, and we have the not that popular frameworks, but they all have their community and their fans. So I don't think it's right now everything is changing too fast. And during this talk, I was talking with the different developer relationship teams of big product-owned companies with a big developer teams. And what they said to me is that they chose their stacks a few years ago, and they stick to that stack. And there is no choosing framework for them because they are already did it. And if you look at the industry itself, yes, a bigger company made their choice. And for some companies, React is a legacy tool. If you haven't heard of the case study of Netflix, how they rebuilt some of their pages from React application to a vanilla JavaScript, then you have to choose, check out interesting article about that. And I believe this is a very good example of how we go back to the native technologies from the frameworks. And the last thing that usually you can hear about the complaining in JavaScript development world is there is a long learning curve to become a front-end developer. And JavaScript and HTML and CSS are just smaller part of what you have to learn before you become a developer. Well, that's life. That's how you become an expert in some areas. And that's just the path of how you become a front-end developer. There's nothing much to say here, right? The employers don't need workers who doesn't know anything, so you have to learn more, and that's unfortunately the sad truth. And in general, if you watch, would look into to some statistics of how what the satisfaction level of the technologies in the past years, you probably will look at some picture like this. So it's kind of small. There is a small grow, but there is a grow. And at this point, you might say, okay. JavaScript is not that bad. Front-end development is not that bad. But is it? Is it? Why? Why am I talking about this? And to be honest, I wasn't too honest with you a few slides before. The actual picture right now for 2020 is looking like this. Yes, the overall happiness was growing from 2016 to 2018, but then it fell back to the smaller numbers. And if you haven't heard of the State of JavaScript survey, definitely check it out. It's a great source that can help look at the trends in the front end. And there is a state of CSS if you are looking for CSS, same statistic for CSS. So why is front end so hard? And this is actually the actual screenshot from the Google page. I believe there are facts that you can cope with. They are just our reality, and you have to work with it. And the first fact is that the browser supports only HTML, CSS, and JavaScript. We have no options to work with other languages or technologies in the browser, just those three. And every tool, every framework, every language that transpiles to JavaScript or preprocessor for CSS or template engines for HTML, they're just syntax sugar for what will be executed in the browser. And actually, some of the new features of the JavaScript language is our syntax sugar. For example, syntax for async await is syntax sugar for promises. That's what we as a developer do right now. Right now in 2021, we using different tools and libraries and frameworks just to work to make our life easier, to work on a little bit different level of development, but we still do need to know basics. And there's a great series of book by Kyle Simpson that explains a lot of things in the JavaScript. If you haven't read it, you have to read it, because you will find a lot of new things in JavaScript and how it works, and probably you'll become a better developer after reading those books. Another fact that I kind of mentioned before is that you have to learn more, and the more you learn, the more you have to learn. Because the path from the junior developer to a high-level developer like senior or lead, it seems like it should be a quick path, but it's not. It's really hard to become an expert in the area that requires a lot of skills and knowledge and knowing not just technologies, but know tools around those technologies. And there are a lot of ads that are kind of trying to sell you that you become a developer in 3 weeks for free, and you can even win an iPhone. This is a screenshot of real ad that I was looking at some website, but there is an actual ad that literally say that you can be a web developer in 3 weeks for free and get an iPhone. But when you're trying to find your first job, there's a different, absolutely different world and requirements from what knowledge you get from the courses or school or wherever you studied the development technologies. Again, this is on the screen. You can see the actual example of the job, the posted job. So I was amazed that as a junior front-end developer, you have to know Django, which is actually a framework for a Python language for backend development. So yeah. I'm sorry for you junior developers. I know it's hard, and I have no good news for you. It won't be easy every year. But let's say you become a junior developer, you develop your career and your knowledge, and you learn during the time, and you become a middle developer. So what? Your life won't be easier. Don't get me wrong. You have to learn even more, and you still have to finish your tasks and show your employer that you're a very passionate developer. If you're lucky and you're on the senior level, probably at that moment you're not even thinking of trying to learn something new. You're just thank you. I'm okay with the technology I am using right now. If you're a lead developer, I know that you probably are hating not just technology, but people as well as technologies. So what to do in that case? Talking from my experience, when I burned out twice for in 2 years, in the past 2 years, try to find work-life balance and try to have more self-care and self-mental care, because it's really important to be passionate about your job and not trying to learn every framework or tool that's coming up every week. And the last fact here, which kind of depends on the previous one, that we don't have time or we don't have resources to look under the hood of the technologies and the tools that we're using. I won't be mistaken if I say that a lot of developers doesn't look at the source code of the frameworks, or I'm not even talking about the standards of the technologies like JavaScript, HTML, or CSS. We just don't have time. There is a reason for that, because we are working for a business. We're working for working to create new features. We're working to make more money for our clients, and we don't have time to sometimes to look thoroughly on some dive deep to some technologies to know exactly how they work, because it's okay to know how to work with those technologies. And sometimes there are bad parts because of that. On the screen, you can see the example of a very bad hiring assumption. So like this, I've seen this that kind of stuff a few times in my career, and that's sad because that leads to very strange decisions when we do not know how the tools working under the hood. We don't know how to work with them properly, and sometimes that leads to very, very strange situation when your project might not be able to be developed in the future. So with all that said, let's go back to the past and the history of JavaScript. A long time ago, in 2095, the JavaScript was born. It was born as a language, like script language for web designers that can do more dynamic on their pages. So it wasn't developed as a hardcore programming language, for example, as Java or other languages at that time. It was small language that could help web designers to do more fun stuff. But during the time, JavaScript became more popular language, and the browsers became to implement this language. But if you know the dark times called browser wars, that was the time when the standard of JavaScript wasn't implemented at the same time, at the same way as it is right now, when we have one standard and all the browsers are implementing it kind of the same way. At that time, JavaScript was very different from browser to browser and worked very different from browser to browser. So at some point at the time, tools like jQuery became very popular. jQuery wasn't the only tool that solved cross-browser JavaScript problems, but it became the most popular library for that reason, for that purpose. And well, the community of front-end developers every year trying to make it dead. You may love it, you may hate jQuery, but at that time it was a tool that helped a lot of developers to build to write better code than they would do it without a jQuery. And even now, you can find a repository that trying to gather different small libraries. I would say utility libraries for pop-up or something like that that are working in vanilla JavaScript, not in jQuery, because a lot of such libraries are dependent on jQuery even in 2021. And very similar tool, I would say, the tool that was created with one purpose and only purpose was a Bootstrap, as an example. So that time, from 1995 to something like 2005, it was time for simple applications. The most of the logic was on the server side. But everything has changed in 2005 when the EDGE came to the browser, and the more application, the more products, web products started to move server-side logic to the browser. And that's why front-end developers need a concept called separation of concerns, which means that different parts of layers in the applications are differentiate from each other. And I believe that it was kind of very logical for the first JavaScript frameworks to use classical architectural patterns like MVC, MVP, or MVVM, because they were working on the backend side for years, and why not to try them in the browser, right? And here comes the very first popular JavaScript framework called AngularJS. It was created by some Google employee who is a side project, and then it was brought to one of the Google project at that moment called Google Feedback. Right now, I believe it doesn't exist, but still it was brought, and they managed to create something that they were working before for 6 months in 3 weeks. 3 weeks, and I believe this is kind of the magic that makes our JavaScript framework so popular even right now. Yes, it is. It feels like magic that you can do big stuff using very small syntax constructions and just a few kilobytes of JavaScript external code. Then there was a lot of different other JavaScript frameworks like Knockout.js or Backbone.js or Ember.js. They actually still exist, but they're not that popular. Interesting thing about Ember is that they were positioned as a framework for creating ambitious application. If you do know what the ambitious web application means, please tell me. I'm very interested to know what it means. I couldn't find answers for a few years now. So that those frameworks are kind of all-in-one frameworks. They try to implement everything that you need to build an application. And they try to do everything for you. And they actually did at some point. But as any tool, it has its pros and cons. For example, the big con for AngularJS is its performance, or performance of the application that built on AngularJS, especially if you're doing it in the wrong way. But here come the React. It was very, it just it just made the whole market of JavaScript framework and libraries just talk about it and try it. And the React is a good tool for that. I'm talking about React as a framework, but actually it is a library just for the view, for rendering. But in my talk, I'm talking about React and its ecosystem and and the tools that you're using with the React to make it feel like it's framework. So if you're thinking that I'm wrong telling you that React is a framework, I know it's not a framework, but I'm talking not just about React, but about the whole ecosystem of this framework, of this library. And yes, React is really a great tool. It's fast, it's light. You can build your dream application using React and a bunch of other tools. You can do almost whatever you want with React, but it also has its drawbacks, because if you're working not with the very architectural mindset, you might not get what you wanted or what you would expect, and the most important, what the client would not expect. Everyone think that okay, we have Angular, we have React, what's next? But there come the Vue.js. I believe that Vue.js is a good framework that combines two greater parts from React and Angular. It's still a framework as an AngularJS, but it's very modular, and you can change different parts as React. And then the new version of Angular framework came up. You may think that this is just another version of the framework, but actually it's totally different framework. It works differently under the hood. The architecture of the framework is totally different. The structure of the framework is different. So I would say it's very similar to compare AngularJS and Angular as you would compare Java and JavaScript. They're kind of similar naming, but they have different concept in it. And right now we have time when modern frameworks are built as a modular framework. So you can you can take one layer from your framework and change the tool that you will be using for this layer in that framework, and you'll have more freedom than you had before. And I think that's a good thing, very good thing, because again, you have more options to work with. When we had three top frameworks like Angular, React, and Vue, the developers came up with another concept of frameworks, frameworks that are more build tools that are actually a framework that working in the runtime in the browser. And here the Svelte, here we have Svelte. Interesting concept. If you haven't heard of it, you should definitely check it out. I would like to talk about another framework called Polymer, but unfortunately not in a good way, not as in a good example. I'm sorry if you're a lover of Polymer or you're a developer of Polymer, but I'm sorry. I believe that this framework is kind of has a good concept, and it is a good proof of concept that web components are working, but the framework itself is not a good concept, and it's not that popular in the community of front-end developers as other frameworks, as you can see. So to sum this up, what do we expect from a modern JavaScript framework? Of course, we would like to have component-based code style. So when you create a new components for your applications, you would like to reuse them and do not create another same components. Of course, you would like to be able to change layers of your frameworks or tools for the layers for your framework. And that's, I believe that's a very important part, because right now we're creating web applications kind of from like Lego, and even if you're working with the framework, you should still be able to change some parts in your framework. And of course, you would like would like your framework to be more extendable. So you should be able to create more functionality than it's going out of the box of the framework. And we all want great performance for our applications that we build on top of JavaScript framework, and we want it just right out of the box. And beside that, we need our web sites and applications, and the content, what is more important, should be visible for search engines. And that's why we do need server-side render and similar tools. And of course, we do want to have a good developer experience. We do want to have good CLI tools. We do not do not want to spend a lot of time to configuring Webpack or similar tools during our process of development. We would like to concentrate on the code and not the stuff around. And you know what? Every modern framework has it. What I mentioned before, whatever framework you pick, you will get those things almost out of the box, or just adding a few tools or libraries that will help you to build those, to make those goals. So yes, this is it. You can choose any framework and you'll get what you need. So how to choose a framework, because sometimes it's really hard to do, and there are a few things you have to think about when you're choosing a framework. First, you have to look at your team experience. It depends on what position you are, but the experience, the knowledge level, your team is very important, because if your team are okay to work with some framework and they are okay to continue to work with that, why should you choose something new? Just to choose or not? Another thing you have to think about it is that you have to understand the technical requirements of the project. Let's say you're starting something new, and you have to think what tools would be a better fit. And maybe there is possible difficulties with this project, that this tool won't be as good as other tool. And of course, you have to think about the deadline. This is very important thing, because the project that has 1 year development timeline and a 2 months development timeline, there are different projects, and you have to think differently on choosing technology for those projects. Or maybe you don't need a JavaScript framework as a framework. You might need something more. For example, there are frameworks on top of frameworks like Quasar or Ionic that can do not just web development on Vue or Angular in this case, but they can create your web applications to a native, convert your web application to a native mobile applications. And I work with both, and I would say it's a good tool if you need more options for building application on different platforms. They are good. They coming with built-in UI library, so you get almost like a big, great platform for creating not just web applications but mobile applications as well. Or on the other hand of this, you might not need a framework as a framework. You might need something more simpler or elegant, I would say. There's a concept called Jamstack, and this is a great concept if you're creating a content websites or content applications that are not so-called admin systems or CRM systems. If you just want to create your blog, for example, the Jamstack is really good for you. A Jamstack is not connected with one technology or framework or tool. It's a concept, and React and Vue, and I believe Angular as well, right now already have some implementations for Jamstack. So check it out if you haven't. So let's sum up what I said before. I said for 40 minutes that frameworks are important, that JavaScript is a bad language and a lot of other stuff. But what is important is the business, is the project that we create and the tasks and the features that we're shipping to the user. And what we are doing here by choosing technology is they're just the tools, and the business and the tasks and the users are more important than any tool that we are trying to choose. And remember that if you know basics, if you know how browser works or how the technology should work, or even standard, it's more important because if you know that, you can learn any JavaScript tool or CSS or HTML tool, whatever. You can learn any tool and you'll be a good developer. So yeah. And remember to find your life work balance and take care of yourself. Even if I say that you have to learn, you have to think of yourself first. And never stop learning, because it is an important thing, because, well, we as a developer should do that every time and every day. Okay, Sasha, but what if I ask you to do some comparison, what the framework is better, what should I choose if I have a team of, let's say, 10 people that do something connected with traveling? Okay, there is a real world comparison repo for you. It's a collection of different technology stacks that are used for example projects. It's a little bit more complex example than you could find on To-Do MVC project, for example. So if you're looking to some comparison for frameworks, actually not just frameworks, but technology stacks, that is the good resource for you. So if you want a comparison, here is the repo for you, and check it out. And remember that by choosing the framework, you're choosing not just npm install something, you're choosing the community, you're choosing the documentation for those framework, for this framework, and the tools that you'll be using along with the framework. You're choosing the articles and the speakers and the conferences and just the community, the people that are talking about this framework. And of course, you're choosing just people that could possibly answer your questions while you be developing your project on some using some frameworks. And again, there is no silver bullet. Each team is different, each project is different, each company is different, and you're not choosing framework for your life. That's the thing you have to remember. Another thing that I wasn't too honest with you during my talk is that there are only 3 technologies in the browser: HTML, JavaScript, and CSS. It's not true, actually. There is a thing called WebAssembly, and this is a technology that allows you to work with different languages in the browser. It's a standard now, so it's official technology, and you can definitely check it out if you would like to work with a different language that will actually be executed in the browser. So and remember that JavaScript development is not just a front end, it's actually a backend development using Node.js, for example, I am a full stack developer, so I use Node not on a daily basis, but very, very often. It's also a mobile development using a React Native or Ionic or Quasar or a few other different options. It's progressive web applications that feels like mobile applications, but they are not. It's a desktop applications using Electron.js and other options for you if you would like to try something new using JavaScript and browser. You can do 3D modeling in WebGL, and you can create your own 3D game in the browser. That's another interesting area to implement your JavaScript knowledge. And if you didn't know, you can do mining crypto in the browser. Please be careful with that, but there is an option if you'd like to try. And the very last thing I would like to say. Do not choose one tool or library or framework that will define your career. Do not become a senior React front-end developer that knows only React and nothing else. Try something new, try something different, and that will definitely help you in the future. And that's all. Thank you for your attention. You can find my slides almost right after this talk in my Twitter. I think I'm ready to answer your questions. Thank you.
Okay, thanks, Sasha. That was super interesting. Thanks for the cool overview. I think there was everything that you can imagine in terms of JavaScript and frameworks. There is one question which maybe is a bit rhetorical, and it also is, I think you gave a good answer in your last advices from your presentation. And the question is how to stop choosing frameworks. And I would say just don't stop, right?
Yeah, sure, for sure. But it's really controversial because to be a really great expert in one framework, you have to spend a lot of time to work with that framework. But that means that you're missing a lot of fun to play with other tools. So you have to try to find some balance between them.
Yeah. Another interesting question: how would you approach developing an own framework?
An old framework?
No, your own framework.
My own. I wouldn't do that because it's really hard to create a universal tool for every project for every team. It's really hard, and what the open source community doing for building the frameworks that I mentioned or I didn't mention, it's an amazing job. I wouldn't create myself a framework because I know it's hard, and why should I do that if I have other options and maybe more smart people that think about the things that I wouldn't even think about, even imagine them. So I don't have an answer for this question, to be honest.
Yeah. Fair enough. Then another interesting question: if you would imagine a perfect JavaScript framework, what would it be capable of?
The perfect, actually, I mentioned it in my slide. So we'd like to have a component-based framework, modular, fast, search engine optimization friendly, and like all that I mentioned before. That would be my perfect framework. And there is no one tool that can do everything for you because every project is different. Every technical requirements for every project are different. So there is no such thing as a perfect framework or tool because the front end is so different and so has so many varieties of everything.
Yeah, I mean the questions are very similar, and I mean I also think that today you just have to be kind of pragmatic and make a decision for what suits best your team and your goals of the project and so on. And then for the next project, it's maybe something different. So you have to adapt, to learn, to take the advantages of what you have. And what
you should definitely know what pros and cons every tool has and why you should use it. Probably this is the most important questions when you're trying to choose something, why you should use it. So yeah.
Then there is a more generic question, not really related to frameworks itself. So Max is asking, actually first he thanks you for the talk, but he's asking what would be a good entry point to become a front-end developer? He's coming from project management and from so where is the question? Yeah, from IT project management, Agile.
Yeah, I would say first learn JavaScript. If you know JavaScript, you will learn any framework that will come on top of the JavaScript. So learn basics and then go. The good options would be either Vue or React. I would prefer Vue in the way that it is a framework. So it has kind of built-in layers and tools inside it. So you're getting the feeling of the framework. And then you can try React. It would be really easy for you. And with the React, you can try really different options for different layers. So that would be my advice. But you can start with React, for example, or Angular or Svelte or whatever. If you know the JavaScript, you'll be able to start to work with any framework.
Yeah. Then maybe also connected to this one. Is it better, in your opinion, to master one framework first or to know a little about everything?
I would say it's kind of in between. You should definitely spend some time not mastering, but to go deep in one framework and then try to switch to others, and not trying to learn all of them at once. Of course, you have to start with something with one framework, and then when you think that you're kind of okay, your skills are good for your current position or a current project, maybe as a side project you can try something new or different or other framework or tool library. If you're feeling that you're not that confident with your knowledge of one framework, of course you should stay and learn more about this particular tool.
Mm-hmm. And then also a similar question, also like thank you for the talk. Basically, what do you think, will there be ever a new framework that is suitable for any projects? I think there can be a lot of philosophy about that, right?
I don't think so, because if we're looking for a backend development, it seems like it's very similar from project to project, especially if you're creating APIs or something like that. If you're looking on the front end, there is no way you can create one tool that will fit all, because the designs are different, the browsers are different, the platforms are different, and everything is different. Users are different. For example, you and me, we would really use one website in a different way because we're different people. And that's why there is no way that one tool, one framework will fit every case and every project and every team. That's why it's so hard to be a front-end developers, because we have to know more, because we're working with the interfaces, working with users are interacting with the interfaces. But server development is kind of more simpler thing, I would say, in comparison with the front end. We have more responsibilities for the users.
Mm-hmm. Okay, we can do a panel with a backend on this one.
Yeah, you can argue with that, but I believe that is true, because we're creating the face of our applications, and that is at least as important as server.
It's an interesting point, and I think there is a truth behind that, because you really have to deal with different people out there using interfaces in different ways. Also, the question was related to, any projects, but what is any projects? Because today, a couple of years ago, we wanted to have nice websites and that, nice buttons and maybe drag and drop. And I remember like 10 years ago or so when we used Ajax for the first time, that was kind of a cool thing. And right now, like also projects and requirements and possibilities change. So what will be the main interface in 10 years? Now we are jumping on speech with this whole Alexa thing and so on. Will it really be the thing that we will use also in 10 years? Maybe not. Maybe it will be some brain stuff. That's changing, and I therefore also don't think that there will be one framework. We will always have new tools, new frameworks, new possibilities, mixes of that. So
and new developers who will develop new tools and frameworks.
Exactly. Maybe at the end we only develop frameworks and they do the job.
Sure.
Kind of. Whatever.
Yeah, a very philosophical question.
yeah, that's true. We could talk hours about that, but let's go to the last question for today, for this session. Also interesting one. Which library framework would you recommend as a base library where you can maybe easily switch to other libraries, frameworks? Maybe Vue?
I believe that's I mentioned it. I would recommend Vue. I myself prefer Vue on other frameworks. I would recommend to try this framework just because it is a framework, but it's modular. Again, you can if you learn this framework at least in a bit, it would be easier for you to change in any direction to React or similar frameworks, or to Angular, more powerful, it feels like powerful framework. So yeah, I would recommend to start with Vue, but if you want something more simpler, then start with React. It feels like it really has a low point of entrance.
Okay, Sasha, so that was it for today. I'm so happy that you have joined us today. So thank you very much also for taking the time to answer the questions. We are going on with the next session and doing a very short break, just 2 or 3 minutes, to get the last speaker of today on stage. So see you in 2 or 3 minutes again.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, welcome back for the last session of today. It was already an intensive but very exciting and interesting day. And the last talk, I think, is something that every developer can take something from with Keren. Keren, how are you?
I'm fine, thank you very much. How are you?
Good, fine. Looking forward to your talk and thanks for joining again. Where are you joining us from?
From Israel.
From Israel, very nice. I've been in Tel Aviv 2 years ago on a wedding of a friend, so you can imagine it was a really cool trip. And tell us, Keren, what will we learn from you today?
So today I'm going to show you how you can use your basic knowledge in JavaScript to create your own Chrome extension. We're all familiar with Chrome extensions such as ad blocker and more. And let's see how we can take our knowledge and put it into use.
Perfect. So, Keren, the stage is yours.
Thank you. Hi, everyone, and welcome to my talk, Extensionator. My name is Keren Kenzi. I'm a front-end engineer at AppsFlyer. My hobbies include singing, photography, and in my not-so-free time, I also study psychology. Today, I'm going to talk about Chrome extension and how we can use our basic JavaScript, CSS, HTML knowledge in order to build our own Chrome extension. Before that, I want to ask you a question. Which is your favorite Chrome extension? You can answer on the Q&A chat and let me know. So before we dive into creating our own Chrome extension, I want to explain a bit about the process and the components that builds the Chrome extension. Basically, the purpose of Chrome extension is to enhance and modify our browsing experience. Chrome extension can include several components. The first one is the background script. Basically, those scripts run in the background, hence their name, and they listen to event triggered by the browser, for example, saving a new bookmark, for example, opening a new web page, etc., and reacts accordingly. The second component are the content script. Those run in the context of the web page itself. They can read and modify the web page. For example, we can use the content script to change the font size, to change the background color, and more. Next are the UI elements. Those can include pop-up, icons, and more. Those elements should be kept minimal as we don't want the experience to be overwhelmed. We need to keep it simple, minimal, and enhance our browsing experience. Last but not least, it's the option page. Basically, it gives the user an ability to customize the extension more. So what we are going to do today is take our basic JavaScript knowledge and create a Chrome extension to help us stay focused on work and not get distracted. Usually throughout the day, we get stressed, we get bored, we get, I don't know, a lot of tasks, and we tend to, for example, open Facebook, go and read something in Reddit, and waste our time scrolling and browsing on different websites instead of focusing on the work we need to do. So in order to stay focused and don't get distracted by Facebook and our friends' feeds, etc., we are going to see how to develop a Chrome extension to do exactly that. Let's see how we get started. So first thing first, what we need to do is open Chromium-based browser, such as Chrome or Microsoft Edge, for example. For this demonstration, I will use the Chrome, and we need to make sure that our developer mode is set. Next, we need to create a folder that will hold all the files for us. I've already created one and opened it in my favorite IDE, which is WebStorm, but you can go ahead and open it on Vim, on VS Code, whatever you feel most comfortable in. with. So let's dive in. So I've created this project and call it WeAreDevelopers. And the first file we need to add in order to create a Chrome extension is the mandatory file called manifest.json. Okay, let me increase the font size. So this file needs to have 3 fields which are mandatory. The first one is the name of our extension. For example, let's call it no distractions. The second one is the version, which will be the version of our extension. We can give any number that we want. We can start with 0.1, we can give it even the version 12, as long as we keep in mind that whenever we update our Chrome extension and update the version on the web Chrome store, we need also to increase this number. So let's start with 0.1. An additional field we need to supply is the version, manifest version, which is currently has to be 2. Soon they're going to launch a new version, version number 3, which will enhance security, performance, and privacy. So those are the fields that are mandatory. Let's go back to our Chrome extension management page. We can access it via this link, or we can either go directly to this link and open it. So what we need to do here is to load and unpack our folder. So this is the web developer. Let's select it. And we can see here that a new extension was added. Currently, it doesn't have much details. We can only see the version, and I didn't set any description, so there is none. And we can see that the icon is something default that the Chrome provide. So let's go ahead and add some description. Let's add set an icon and continue from there. So if we want to set an icon for our extension, we need to set the field icons and provide image in different sizes. The mandatory one is 128. This image will be used as the image as the icon during the installation of the extension itself. We can also provide a 16 by 16 icon, which will be used as the fav icon, and 48 by 48 will be used in the manage extension page. Don't worry if you have only one icon and you don't want to, and you haven't provided any other icons, Chrome will take this one and set it and resize it to fit the different sizes. For example, I've already pre-downloaded this icon from Pixabay, and I'm going to use it as the icon for the extension. Let's add a description. Helps us, for example, helps us stay focused on work. And let's go back to the web management, Chrome extension management page and refresh. We need to keep in mind that whenever we update our code, we need to go over here and refresh it. Now you can see that a nice icon was added, and also we have the description displayed over here. As I mentioned before, one of the components that are included in the extension is the background script. Basically, we want to use the background script to add the logic for our extension, to listen to a specific event. In our case, when we are opening Facebook, for example, and we want to stay focused on work and prevent this from happening, we need to react to it in the background script. So in order to add a background script, I need to add additional field over here. And it's an object which has the following scripts field key. Here, I should specify the file I want to use as the script. Let's name it background.js and go over and create it. So let's open a new file and give it the same name. So what we are going to do here, I want to create a Chrome extension that whenever I try to open Facebook, I get redirected to wearedeveloper.com/live. How do we do that? So basically it's listening to events and reacting accordingly. So in order to do that, I want to use the Chrome API. If we want to use the Chrome API, we can go over and you're using WebStorm and you want it to be autocomplete, you can go to WebStorm, click on Preferences, and in Languages and Framework, make sure that under JavaScript libraries, you have this one downloaded and selected. Okay, so I have already set it. So I want to use Chrome and I want to use the Web Request API. When I use the Web Request API, I want to catch the request to open Facebook even before the TCP connection happens. So I'm going to use onBefore request and add a listener. The listener receives 3 arguments. First is the callback. Second one is the filter. If I want to limit this reaction to certain URLs and not just block every URL I try to open. And the last one is optional extra information for it to use. So for this one, I will create a function. The function, this is the callback function. And what I want to do is I want to, let me just a bit. What I want to do here is to catch and redirect the request to a different website. So I want to use return. And what I want to do here is call redirect URL. And instead of going to the Facebook page, I want to go to wearedeveloper.com.live. So let's open in a new tab and copy this URL, go back to our extension and paste it over here. But I don't want it to happen every time. I just want it to happen when I click, for example, on Facebook, which is my guilty pleasure. What we want to do here is after the function, we need to set a filter. This object receives the URLs, okay? And here I can provide several URLs. For example, I can say that I want to catch every time I'm going to facebook.com. Okay, so now we have the filter set. It limits the triggering of this event. And we need to supply a different thing, additional thing, which is the optional extra information. In our case, we want to set it to blocking, which means that we want to wait for this operation to be synchronously. We want to wait for the callback to return before any request is made. So that's about it. We are adding a listener. We are redirecting every time we want to access Facebook. We want to redirect to the WeAreDeveloper. And the manifest, I've added in the manifest the background.js script. So it should work. But every time I use Chrome APIs, I need also to request permissions. I'm going to show you how you can see errors in the manage extension page, just to demonstrate how you can debug, how you can view additional information in case there is an error. And then I will go back and correct this error and request the relevant permission. So let's go over here and let's refresh our extension. We can see here that there is a background page. Here we can add console, etc. And we see an error, cannot read property on before request of an undefined. As I told you before, I haven't requested the permission yet. So what we need to do, and we can see also the errors over here, is we need to request permission to use the web request. So let's go back and add additional field, which is permissions. And we need to request permission for the web request. And as I was using blocking, I also need to use to ask for permission for web request blocking. Let me just move. Okay, so that's about it. And as I'm trying to get permission to Facebook, I also need to add an auth permission. So let me just copy paste it from here. So I need to request permission for from Facebook. Oh, sorry about that. So now it should work. So let's go back, clear the errors, go back and refresh our extensions. So no errors are found. So, and when I will try to, when I would try to access Facebook, what it happens is that I get redirected to the wearedeveloper.com/live. Of course, you can redirect it to Stack Overflow, for example, or your working namespace. Just choose a website that you want to redirect it that is relevant to your work to remind you to stay focused and don't waste time scrolling Facebook and seeing feeds from friends, because you can waste a lot of time just scrolling. So that was the first extension. If you want to see the code, you can find it, scan this QR and find it on the repository. Hope you learned something new. Let me know if there are any questions. And from here, I'm going to show you the second extension. So a lot of us have been working from home in the past year due to COVID and everything. And as we have our boundaries between work and life has become a little blur. And what we want to do is to set ourselves a reminder to stop working, to clock out, and spend some fun time with our families, with our friends, to focus on our hobbies and stuff like that. And don't exhaust yourself with work and everything. As Dolly Parton said in her song, working 9 to 5. So let's try to keep it to 9 hours. If you want, you can set it to 12. And what we're going to see here is how we can set ourselves a reminder to stop working after a certain amount of hours. If you insist, you can work 12 hours. It's your preferences. Just make sure you balance your life with a little of fun activity outside of work. So I'm going to show you how to create a Chrome extension that sets a reminder and display notification to stop working after a certain amount of hours. So let's dive in. And I've already opened WebStorm on a new project. I've pre-downloaded 2 images that I want to use for this extension. You can guess why. And as before, the first thing we need to do is to create a manifest file and give it the mandatory fields, which are name. Let's give it a clock out reminder. Let's give it a version number. Let's say also 0.1 and the manifest version, which is mandatory. Set it to 2. Let's add a description. Helps to balance our life. And that's about it for now. Let's go over to, I can close, never mind. So let me just switch between them. Okay, so let's go over here and load and unpack our new extension. So let's go over here. select. We can see that a new extension was added with the description and the details. Let's add an icon as before. This will remind us the steps again. And as I said before, we need to provide this image. So let's call it stop working. Let's use the stop working icon. Forgot to add it. Okay, so what I want to do for this extension is to add an icon over here next to the address bar that will open a pop-up to set the reminder. In order to do that, and as it is relevant to all pages and not to a certain page, I'm going to use something called browser action. We use this one when we want to activate our extension on all pages. So let's add the browser action to the manifest. Just a second. Try to. Okay. So let's add additional field. Sorry. For the browser action, we can set several things. We can set a title, an icon, and a pop-up. So let's start with the default icon. We will use the same one as stop working. And let's add a default title, which will be the tooltip that will be presented when we hover over the icon. So default title, which is clock out reminder. And we can set the default pop-up. We haven't created it yet, but we can declare it, and afterwards we will go over and create it. So let's copy paste it. And what we're going to do here is add a new HTML file for the pop-up, name it pop-up, and let's add something. So first thing first, let's add an H1 title for our extension, call out, clock out reminder. In this extension, you can see how you can put your knowledge to use, knowledge of HTML and CSS and not just JavaScript. So it's a bit like, it's a different extension example. Let's add an image. And the source, let's use stop working again. And let's add two buttons. One for setting the reminder, and the other one is for canceling the reminder. So let's give them an ID to differentiate between the two. So the first one will be a reminder. And let's say we want to set reminder. And the second one, I will just copy paste from here. And, oh, sorry. And let's give it a different ID, call it cancel. And this will be cancel reminder. Let's see our extension. Let's go over here, refresh it, and we can see the icon was added. And if I click here, I can see a new extension that I can pin to the toolbar, which is clock out reminder. And if I click on it, a pop-up is opened. But I want to set a different bit to change the CSS so it will look good and not like this, to keep it minimal. So let's go back. Let's set the width to 200 and the height to the same. Let's give some styling to our CSS styles. So I've already created some CSS stuff to not waste time on colors and such things. So I'm going to take it clock out. Let's copy paste it from here. I will show you in a bit the styling so you can see. So I basically just gave a text alignment center, set the font size of the header, and set a bit of padding, margin, etc. to the button to make it look better. So that's about it for our extension. And next step, we need to do something when we click on the reminder, right? Currently, we don't have any script that does something. We don't have a click listener. So when we click on the buttons, nothing will happen. So for that, we need to add a script. Source, we call it popup.js. And as you guessed, we're going to create it. So let's go over here, new file, new JavaScript file, name popup. Okay, so what we want to do here is to use the document API and to add listeners. So let's go over here, use get element by ID. As you remember, I gave it an ID reminder. And let's add event listener. This event listener is for click. And when a click happens, I want to set reminder. Okay, the second one will be the same just for the cancel button. So let's go over here and get element by ID cancel. And what I want to do here is to cancel the reminder. Okay, so let's go and create the functions. So here what we want to do is to set an alarm. I forgot to tell you one thing. When we set the pop-up and set the reminder, we can give it a value. The value should be the number of minutes we want to work each day, because the delayed is in minutes. So we want to use, for example, if we want to work 9 hours, the value should be 540. For the current demonstration, I will set it to 1, so we don't have to wait 9 hours to see the notification, but you can change this to whatever number you like just to see how it works. And let's go back to the pop-up. And what I want to do here is to use the Chrome Alarm API and create an alarm. The alarm the create receive an object which has delayed in minutes. As I told you before, we can use the event.target value. Of course, we need to parse it to an integer, but for this demonstration, I will set it to 1 so we won't have to wait. And basically what we want to do here is whenever a user clicks on the alarm, on the button, I want to set an alarm and listen to it on the background script, which will react accordingly and create a notification. An additional thing I want to do here is to close the pop-up. So I will call window.close. And for the click, what I want to do here is to, for the cancel, I want also to create a function named cancel reminder, which will do the following, Chrome alarm. And here I want to cancel all alarms. And again, window.close. Okay, and now let's go and create our background script. What we want to do here is to listen for the alarms. So I'm going to use Chrome Alarm API, but this time on alarm, and add listener. And what I want to do here is to basically create a notification. So, additional thing I forgot, sorry about that, is that we can, when we have an extension, we can set a badge. Basically, it's an indication up to 4 letters, which tell us the status of the extension. Let's just refresh to see our changes so far. We can see that we have a nice, nicer looking extension. Okay, let's go back. And here, and when I set a reminder, I can also use Chrome and use the browser action and set the badge text. This will give us an indication that we clicked and set on a notification, a reminder for us to stop working. And when I cancel the reminder, I want to do the same, just to set the text to off to indicate it that I've canceled the reminder. And let's go back to the background. So here I'm listening to the alarm and I want to display notifications. So what I want to do here is to use the Chrome notification API and create a notification. The option for creating a notification includes several things, such as type, which is basic in our case. We can also provide an icon URL. Let's choose for this one, need sleep. And of course, we have title, which will be clock out reminder. Clock out, and we can set also a message saying time to stop working and have some fun. And also, because I want the notification to remain active as long as just to make sure that I haven't missed it, like I don't want the notification to appear and then disappear before I notice it, then I need to add a requires interaction to requires us to interact with the notification and cancel it manually. So that's about it. I just need to go back to the manifest and add the background script. Background. And let's add it over here. Let's add the scripts, which is the background.js, not with a capital letter, sorry. And we also need to permissions again. This time I use permissions. I use the alarm API and the notification API. So I need to use notification and alarms API. Now let's go back, refresh our extension and see if it works. So I don't see any errors. I see the background page was added over here. And if I click on the icon and set a reminder, I can see that the badge was turned on. If I cancel the reminder, the badge is set to off to indicate that I've canceled the reminder. And let's turn it on again, just to see if we can see the notification. Hopefully everything will work and you can see it. This is the longest minutes ever. So let me know what you think and let me know what reminder you want to set to yourself, whether it is a reminder to take a break, stretch, drink some coffee with family and friends, etc. It really helps us to stay energized and to be more happy and have a more balanced life. Let's see, let's wait for the notification. By the way, if you want to add your extension, oh, I can see that I have errors. Unable to download a specific image. I guess I made some mistake in the need sleep PNG. Let's go over to the, sorry about that. I forgot to add need sleep. At least we know it's working. And of course, in a live demo, everything can go wrong. So let's see again, we have the reminder, let's set it again. So as I started to say, when we want to upload your extension to the web Chrome store, what we need to do is to create an account and upload it to the store, and it will get reviewed and either approved or not. Hopefully it will be approved. And that's about it. So I hope to inspire you to write your own Chrome extension. You can see that you could get started with even the basic JavaScript, CSS, HTML, and just have fun with it. For myself, I've created a stretch reminder because when you work a lot of hours in front of the computer, you tend to forget to stretch, and then there are back aches and stuff like that. So doctors recommend to stretch every 30 minutes, to move, to change position. So I set myself a reminder to do that. And so you can see the notification. If I click on it, you can see that clock out. It is time to stop working and have some fun. And that's about it. If you want to see the code for it, it requested an interaction. So I will just close the notification. And if you want to see the extension and the code, it's available over here. Just scan the QR. And I want to thank you very much for joining this talk. If you have any questions, feel free to reach out. This is a link to my LinkedIn profile, and also this is the Twitter. And feel free to reach out and if you have any questions. Thank you very much.
Keren, thank you so much.
Sorry.
Just some audio problems. Okay, thank you so much for this presentation. I never did a extension myself, but I will definitely try that out. Sounds very, very interesting. There is indeed some questions already, so let's jump right into it. Can you hear me? Actually?
Yeah.
Okay, perfect. So I think there was some audio problems. But yeah, just said like super interesting. I think everyone can do it in a couple of minutes to start maybe with a own project. I will definitely try it out. And there is some questions. So one question is, can multiple extensions communicate with each other?
Well, it's a good question. I haven't tried it myself, so I'm not really sure. I know that the context script and the background script can communicate via messaging, but I haven't tried it. And I need to check it because usually it runs in the background as long as the extension is alive. So it should be possible, but I'm not sure. I need to check it and get back to you.
Okay, then another question is the storage limit for data if you put a extension in the store.
I haven't tried to upload it to a store yet. I'm just using it locally from my experience, but you can see all the relevant information also in the documentation of the of developer.chrome website, and you can try over there. I don't think there is really much limitation. They're just checking the code to make sure everything is okay with it and reviewing it. It doesn't do any manipulation it shouldn't, etc.
Yeah, okay. I also think that the developer website of Chrome is always a good starting point to get answers for these kind of questions. Another question, also tricky, is it possible to make extensions to work cross-browser, and what would be needed? So I would say definitely yes, because there is something out there for that, just with the API. Or?
You need to set the relevant, whenever you want to use some a cross extension, or you need to specify a certain permission to do that in order for it to work. So you can try this one. Whenever you want to access a specific page, you need to add, for example, all URLs if you want to use to get access to all the URLs, and bypass the need to cross a region limitation and more.
Then two more questions. One is how to make a search bar with which retrieves the entry. Then in the database, all the lines which contain the entry are displayed on the screen.
Search bar. Well, whenever you create, let me see just the question again. I want to make sure that I understand it correctly. So whenever you search, for example, when you search on Google or whatever, you can catch the request and you have details. If I show you, for example, the details of a web request, you can see in the URL of the details, you can see exactly what you search for. For example, if you search on Google, you can see in the URL the Q equals and see the query parameters. You can then use JavaScript to take that just the search parameters, the query params, and run a search on your database to extract all the relevant information.
Okay, and the last question, what is the most complex extension you did so far? I would add a personal question also, what is your favorite own extension?
Definitely ad blockers for YouTube. Sorry, but I just can see all the promotions and stuff like that. What I did is I played around with the Chrome extension and tried even to take an extension to take a search in Google and transform it to a search on GoGoDAC, so to get different answers, and just play around and create several reminders for myself, and also a reminder to whether to report my working hours, etc., and stuff like that. So basically for my own use, just to keep me more productive and stuff like that.
Okay, perfect. That was already the last question. So Keren, thanks again very much for joining us. I hope to see you soon also in person at an event of WeAreDevelopers sometimes in the future.
I hope so.
Greetings to Israel and see you soon again.
Thank you very much. Have a great evening, everyone. Bye-bye.
Thank you. Bye. Okay, so that's a wrap up for today. This was the last session, and we have 2 more days to go, so we are not over yet. And tomorrow it will be also a very interesting day. We will talk about, for example, how to build UIs that learn, so some combination with AI stuff. We will talk about Vue.js, we will talk about TypeScript, we will talk about building friendly Kotlin SDKs to connect with JetBrains Spaces. So there is kind of a variety tomorrow for our talks. And with that said, I wish you all a very nice evening and see you tomorrow again. We start at 1 p.m. sharp.
Business go hybrid. When you're a chef running a kitchen,
Artichokes, please.
Things can change quickly. The branzino isn't selling, the ribeye selling out. My floor manager's wife just went into labor. Getting things prepped beforehand can help you put out fires. Literally. That's what a hybrid cloud approach with IBM can do for your business. It lets you automate processes across all of your clouds to get ahead of problems and earn rave reviews.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.